Welcome to the Toronto section meeting of the Society of Motion Picture and Television Engineers. The SMPTE is the world's leading professional engineering society in the fields of motion picture and television. The society serves the industry by disseminating technical information as well as providing leadership in the standardization of equipment, materials, and practices. Every month, the Toronto section organizes a meeting which allows you to participate in programs of interest and importance. We hope you enjoyed tonight's presentation. If you are not already an SMPTE member, you are encouraged to join the society. All you need is a clearly defined interest in some phase of the industry. As a member, you will receive the monthly SMPTE Journal to keep you informed of the latest technological developments. As well, you are entitled to discounts on society publications and conference registration fees. And each month, members receive the News and Notes Bulletin with notification of the monthly meeting. Consider becoming a member. Pick up a membership application tonight. With technology advancing so quickly, it is essential to be well informed. The Society is dedicated to serving the members of the motion picture and television industries. Why not join us?
Good evening. I'm David George. 12 short days ago, I became the immediate past president of the SMPTE. I'm also a SMPTE Fellow and a member of the Toronto section of the Society. I have been your host for the last 11 satellite distributed meetings of the Toronto section, and I am privileged to be your host again for our 12th show tonight. Each time, CanWest Global Television has made facilities available to originate this program to our members and friends across Canada and in the United States. This year, Fifth Dimension Television is once again the provider of facilities for satellite distribution. On their behalf, I also bid you welcome to the program. I also want to pass on to you greetings from our SMPTE Canadian governors and society executives who are with us tonight. First, Sir Fung Lam, who is the section's vice president of the SMPTE, and Mr. Edward Holmes, a Canadian governor and the producer of this television extravaganza. These live electronically distributed meetings were introduced 13 years ago in recognition that many Canadian SMPTE members and others active in the motion imaging industry live, learn, and work outside of the major centers in which the society is active. They cannot attend monthly meetings and through them gain access to contemporary technical papers or tutorials as regularly offered by local sections. Nevertheless, all of us who are involved in the motion imaging arts and sciences in virtually any capacity are impacted by the rapidly changing technology of our industry, no matter where we work and live. With the help of CanWest Global Television and others, we have tried to overcome some of that isolation with our several earlier programs on emerging technologies, all of which had a growing focus and emphasis on digital television. In the past, we have concentrated on the technology, but tonight we will focus on Canada and the Canadian challenge associated with and the Canadian response to the introduction of digital television, or DTV. While we recognize that Canada has little practical choice but to follow the US in the introduction of DTV, adopting the same standards, it does have some opportunity to do so in a somewhat different way. I would suggest that the economics and character of the Canadian broadcasting environment argues for a more constrained and cooperative approach than that taken in the US. Coupled with the realities of Canadian geography, signal distribution, and demographics, the economic case for broadcast DTV in Canada is even less attractive in the early stages than it is in the US. Tonight, with the help of several industry leaders, we will be exploring and discussing this issue and finding out where it is we stand. First, to gain an appreciation of what has happened in the United States, Stephen Pumple will bring us up to date on the US experience. Carol Darling will then address the realities of DTV broadcasting in Canadian terms, and Lou Montana will discuss the technical approaches that have been proposed. Roger Key will then introduce the position and role of Canadian cable in this scenario. Following a short break, and as part of a panel discussion segment, Terry Snazel will provide some insights on the DTH approach to DTV. Bruce Cowan and Jim Rogers will then offer a Canadian broadcaster's perspective, and Harvey Rogers a specialty broadcaster's view of DTV. The panel will then explore these positions among themselves and also be open to questions and comments from the floor. To make this dialogue more useful, distant viewers are invited to participate in this program along with their local audience. Questions will be welcomed at the end of each presentation and at the end of the series of presentations as well, to the extent that time will allow. I would encourage you to get your distant questions in early. Toronto section members here will take down any questions you may have and ask them for you. To ask a question or to make a comment, simply phone this toll-free number, 1-800-265-4133. Please tell the member who answers your location, name, and whom you would like the question addressed to. Remember, it is better not to wait until after the presentation has concluded to register your distant question or comment. You can do so at any time. So don't let the opportunity pass you by. You should also note that it is the policy of the Society that questions of a purely commercial nature not be addressed at these meetings. We have a very interesting evening ahead. As a place to start this discussion, I would like to offer an opening perspective from which we can begin our exploration of tonight's subject. Let's call this viewpoint the Canadian challenge view. It's rather cynical, but it does provide an opening context. And the view goes something like this. In the United States, television broadcasters are already converting to digital transmission. This is not being done, it is argued, because the viewing market demands it, or because it makes economic sense, but rather because radio spectrum is considered a valuable public resource, television is seen as squandering it unnecessarily, and more utility and value can be realized from its sale to other communication services. Thus, the US DTV scenario was mandated by law in the public interest. In truth, the legacy of conventional television transmission does not make very efficient use of spectrum in today's terms and leaves many large unused gaps between channels and between locations that, if cobbled together, would be valuable for other forms of fixed and mobile communications. And in addition to offering the possibility of high-definition television, HDTV, or several channels of standard definition service, SDTV, digital television channels can be packed closer together, and thus the same number of television services can be supported by much less overall bandwidth, freeing up unused frequencies for other commercial uses. The opportunity to free up spectrum in this manner is limited, and the need for underutilized television frequencies for communications use is pressing. Recent developments in digital technologies have made it technically possible to convert existing broadcasting to DTV. Now then is the time to bite the bullet and make the move, and the pressure is on to make it as quickly as possible. However, broadcasting is a free service, a public service, and the public also has invested in television through the ownership of devices which would be rendered obsolete by this change. Politically, some reasonable period must be offered for the conversion to allow the public to reap some return from these investments. This dictates the interim operation of a parallel DTV system while the existing conventional NTSC systems remain in place. This is made possible because the nature of the digital transmitted signal is such that it can occupy those unused channels now lying dormant in the television service frequency bands without interfering with NTSC or having the NTSC channels interfere with it. Thus, a channel assignment plan has been worked out such that every existing television broadcaster in the United States has been assigned a second television channel for DTV service. And that plan includes Canadian stations in the area near the border with the US. Now, this is an area in which some 80% of Canadians live. In the first phase, these new US services will be implemented in the now unused but still reserved television spectrum. As there are few receivers, little audience, limited revenue, and the DTV signals are more effective, lower power operations can satisfy the initial needs of the broadcaster to be on air. As DTV builds an audience, however, more emphasis will likely be placed on optimizing that service, even if it means some compromise to NTSC transmissions. Eventually, the full audience will have been converted or can be served by DTV, and at that time, the FCC will cause NTS service to cease, finally freeing up all those NTSC channels. In the next phase, the FCC will repack the DTV broadcasters, which will then be operating in a patchwork quilt of television channels with previous NTSC service channel holes, into a contiguous segment of the lower UHF and upper VHF television bands. This in turn will free up a large quantity of valuable spectrum for general communications use, especially at the upper end of the current UHF TV spectrum. Segments of this spectrum will then be auctioned off to the highest bidders, and finally, new services will be possible, and the government, on behalf of the public, will realize revenues from the sale of this public resource. This, the scenario says, is the pressure behind the timely introduction and conversion to DTV. So how soon will this conversion occur? The FCC has mandated conversion of conventional television broadcasting to digital broadcasting by the end of December 2006. They have specified an ambitious program that would see NTSC broadcasting cease then, and that's less than 8 years away. Canada has no real option but to adopt the US strategy, but is generally considered to be some 18 months to 2 years behind the US in the introduction of DTV. As there is with NTSC, there will be an off-air spillover of DTV signals into Canada from US border areas, to Toronto, to Montreal, to Vancouver in particular. Also, both US and Canadian DTH broadcasters are technically poised to offer HDTV or quasi-HDTV services if they choose so. So DTV service will become a factor in the majority of Canadian households, whether we embrace DTV as a Canadian alternative or not. We must remember, however, that the challenge of Canadian DTV service is no less in terms of technology and more perverse economically than in the US, given the character of the Canadian market and the unique set of demands placed on Canadian broadcasters and on the Canadian broadcasting system. Unlike Canada, the US has a large and rich off-air television market and few cultural protection concerns. While still difficult, it is easier to make a business case for DTV in that environment than it will be in Canada. And American broadcasters have not put forward a business case yet that even they find very encouraging. Most efforts have focused on consolidation with fewer but larger owners operating multiple stations, some offering multiple services, in several markets, betting on realizing longer-term operating efficiencies and growing overall national market share. With a few exceptions, Canadian audiences are smaller, more scattered, and less valuable to television advertisers. If anything, Canadian television operating costs are higher than those in the US on a per capita base, and Canadian programming and cultural responsibilities greater. Arguably, the backbone of Canadian television distribution and the main instrument of television public policy in Canada is, and for a long time has been, Canadian cable television, now joined with the relatively new Canadian satellite services, and this further complicates the Canadian DTV issue. Canada is a highly cabled country when compared to the US, and cable accounts for the vast majority of consumer television signal distribution in Canadian urban areas. Cable, too, provides the main technological gateway that permits some degree of control of US signal ingress into Canada and the operation of certain important broadcast business tools, like simultaneous substitution, which helps Canadian television stations by delivering Canadian audiences to Canadian broadcasters. Cable in Canada will have to play a key and early role in the distribution and delivery of Canadian digital signals if anything like this level of cultural and economic protection is to be maintained. That will require a further significant investment on the part of the cable operator in addition to that of the broadcaster. And all of this must be financially supported in one form or another by a total television audience only about 10% the size of that in the US market. In fact, the total U.S. off-air potential audience alone is greater than 3 times the potential Canadian total audience, taking off-air cable and satellite altogether. So if you buy this scenario, you will agree that Canadian broadcast economics argue for a simpler, less expensive system in Canada than in the U.S., and our Canadian psyche, I suggest, permits consideration of a more cooperative and less independent approach to service delivery. Further complicating the matter is the U.S. sensitivity to Canada's efforts to protect its cultural industries. And you can bet they will be monitoring our efforts to retain existing protections in a DTV environment. So it's not going to be very easy. The good news is that already there are Canadian initiatives aimed at limiting the options, variability, and costs of the introduction of DTV in Canada, and we're going to hear much more about these a little later on. Before we do, however, given the context I've set out, now let's look in a little more detail at what's planned and what's happening in the United States through the eyes of someone who is active in that television market. Stephen Pumple founded IMAD Broadcast Services in 1974. He graduated from Ryerson's Electrical Engineering Technology program and holds an MBA in Business Administration from New York University and a management diploma from the Purdue School of Management. Formerly president of IMAD, now chairman of IMAD ECVS, with offices both in Canada and in the US, he is involved in strategic planning, business development, and acquisitions for its parent and public company, Asgar Technologies. Stephen has designed, built, and managed studio, transmission, microwave, satellite, and local area network projects throughout the world. He was active in the design, implementation, and operations of City TV Toronto, the Global Television Network, and the CBC Accelerated Coverage Initiative through the 70s. He was involved in the design and implementation of the host and domestic 1988 Winter Olympic facilities in Calgary, the 66 Summer Olympics in Atlanta, and more recently the 1998 Winter Olympics in Nagano. He managed the design of the EchoStar facilities in Cheyenne, Wyoming, installed and assisted in the design of the lands for the DirecTV facilities in Castle Rock, and he has worked throughout the United States and Canada, the Middle East, South America, Africa, Europe, and Japan. Stephen's company is already busy with the development of digital television and DTV facilities in the United States, and he can share some of that firsthand experience with us. Please join me in welcoming Stephen Pumple. Stephen?
Thank you, David. Let me get this thing running here. We on? Good evening. My name is Stephen Pumple, and I work with IMAD CVS, a system integration company here in Markham and Boonton, New Jersey. Most of our work is in the design and conversion of broadcast facilities in the United States, moving them from component analog plants into the digital infrastructure, and in a number of cases, digital television facilities, which are now operating in the U.S. Whoops. Tonight I'll give a brief overview of DTV, talk about our work in the meetings in the U.S., where we have noticed that the acronym appears to confuse a lot of people. DTV is a complicated subject, and my presentation is a brief summary of DTV. I'll talk about the FCC schedule, review the schedule for the conversion from analog to digital television, and the simulcasting window, the FCC transmission rules, the carriage, U.S. carriage rules must-carry rules for cable, the U.S. network plans, what the networks are doing, including what DirecTV and EchoStar have announced at the CES show that they're going to be doing. Talk about some of the issues which this conversion is bringing to the forefront. Also mention some of the highlights at the recently held CES show in terms of what's happening with the consumer products. And the speakers following me will talk about what is happening here or going to happen here in Canada. Some of the material I'm presenting, you may have seen. Some of it was already presented by Pat Whitting a month or so ago. What does DTV mean? DTV refers to the over-the-air transmission system. Using MPEG, the MPEG-2 compression scheme, there are two primary systems. In Europe, there's the DVB system, and here in North America, in the United States, Canada, and probably Mexico, will be the ATSC system from the American Television Standards Committee. This is the one we'll be focusing on this evening. Perhaps some of the difficulty we see people having understanding DTV is due in part to the fact that there are many formats you can have shown. And these are set out in ATSC Table 3. DTV is a transmission standard. It's not a production standard, nor is it an internal signal distribution standard. By definition, DTV, or HDTV, has at least twice the horizontal and vertical resolution of the NTSC signal. Each format has a series of options which ultimately determine the overall package presented. They include scanning choices, whether it's progressive or interlaced, program options, what sort of information or data is being transmitted along with that signal. Will it be run in the same format all day, or are they going to change during the day and run perhaps an HTV signal during the evening, prime time, and then run multicasting during the rest of the day? You got optional frame rates of 24, 30, and 60 frames a second, aspect ratios of conventional 4:3 NTSC or 16:9 in high definition. And the audio, HD3 audio, which gives you a left, right, a left, front, left and right, rear, left and right, and a middle, plus a woofer, subwoofer. And if you haven't heard a full-blown ACS3 system running, then you should do it, but just leave your wallet at home. Digital Dolby sounds absolutely phenomenal. This is the ATSC Table 3. And if you look at it, you'll notice that it offers several options for each of the scan and frame rates. And this is how we get to our multiple choices and how the broadcaster looks and decides what they want to do, and then what formats they're going to have to use to do it. And DTV is sort of a chameleon. You know, it's all high-definition transmissions are in DTV, but standard definition television, which is digital, is not HDTV. And it's the DTV in the SDTV, which we have found in talking to clients and people we work with in the United States, that confuses a lot of people about what we're really talking about when we talk about digital television. And the display devices that we're using at home, and will continue to use at home for some length of time, remain analog. And although they get digital decoders and signal processing equipment to feed them, they're still analog devices. The DTV transmitter takes its signal in as a 1939 megabit data stream. And there are many options available to the broadcaster as to what's in that stream. It can have a single 1920 by 1080 interlaced HDTV signal with some data, or it can have a 1280 by 720 progressive high definition signal and a 720 by 480 progressive standard definition signal, or it can have four 720 by 480 interlaced program feeds, plus a data stream, and the data stream is dependent on what the program stream is and what they're trying to do with it and what they're trying to take advantage of other technologies with. There are lots of options for the broadcasters and the marketing people, and much room for them to experiment with marketing ideas going forward. This chart sets out the options available, and there's nothing to say that the broadcaster cannot move between the different channel plans throughout the day. There are many services that are yet to be discovered by marketing people and people who have never been told what television can or cannot do. There's interest in running various data streams on the data channel. and I have no doubt that the marketing people will find ways to take advantage of this technology in short order. The FCC has set out a transmission schedule that requires the transmission of over-the-air of the ATS signal to the public, the conversion time frame from analog to digital, and the window for simulcasting and the conditions imposed on it in doing that. The top 10 markets had to be running by May of this year, which covers 30% of the U.S. households. The next group from markets 10 through 30 by November of this year for a total of 53% of the U.S. households. All the commercial stations had to move by May of 2002 or be transmitting by May of 2002. The non-commercial stations such as PBS transmitting by 2003. And as we'll see later, this has introduced some new options for the public broadcasters and proposed rulemakings that the FCC has recently announced. Then we have the question of all the LPTV stations in the United States, and there are many of them. Most of the DTV conversations center around the 1,600 or so Class A stations, but LTV represents a real interest. And at a recent AFC meeting, or the Association of Federal Communications Consulting Engineers that I was at in Washington in November, the FCC was there to put on a presentation to the various lawyers and engineers talking about the move of LPTV stations into the digital domain and some of the options that this might give them. The following is a graphical rollout representation of the DT transmission schedule, beginning with the announcement in April of 1997 by the FCC. And as you can see, the schedule is, as I said before, and in fact it turns around, we're ahead of that schedule now. For the broadcasting of digital transmissions, all stations must broadcast 75% of their analog programming by digital by 2004, and that they must simulcast 75% of what they're transmitting in analog. And it must become 100% by the year 2005. The present schedule is that the transmission of NTSC, as we know it today, will see its demise at the end of December of 2006. There are some conditions will cause that not to happen. I'll mention those a little later. There's an assumption that set-top boxes will be available for decoding the DTV signals for the many millions of analog televisions which will continue to run long after the demise or expected demise of NTSC television. When the UK went from 408 to 625 years ago, they did it on a 15-year schedule. And I remember reading an article that talked about the fact that they shut down the last 408 50 transmitter plant, and the government had actually bought 1 or 2 TVs for some people. This is the transmission timeline that sets out the conversion from analog to digital. This does not cover LPTV, which is coming. And this chart also shows, on the lower line, a parallel of the simulcasting period. This chart here is a simulcasting explanation, but what's notable about this is that up until April of 2003, television stations are entitled to do whatever they want in the DTV range, provided it's legal, experimenting with the signal, and experimenting with ideas and what they can do with teletext. They can run downloading PC programs. They can run interactive television. There's all sorts of ideas that people are fooling around with here, and they don't have to do anything in particular until 2003. And this will let them figure out to see the market is going to determine what's going to happen here. Much like there's a financial model which we're having trouble recognizing here in Canada because of the numerator-denominator equation. And in the United States, even though the market is larger, there's a huge capital outlay for some of the stations. Some of the American stations do it up much larger than we do it here when they do a transmitter plant or a television station. They have the numbers and the eyeballs to count for that when they're selling their time, but it's still a huge number. So the financial modeling for DTV is far from complete, and this experimentation is a component of that model. The FCC has decided that the decision regarding what programming, ideas, and applications of technology are incorporated into DT has been left to the forces of the marketplace. Broadcasters will try a combination of high definition, multi-channel, standard definition, data broadcasting, interactive television during this time period. There will be much testing and experimentation on all of this, and it certainly has the ring to me of the days when AM stereo was developed in the United States, and we had a number of systems running, and it was buyer beware if you bought a radio that wasn't multi-standard, and we know that that was not a very successful program. The FCC transmission rules. The Reader's Digest version of the transmission rules is that the stations must transmit at least one program stream of equivalent quality to the analog NTS signal, and it must be free to the viewer. Stations must also transmit this signal during the same time as the analog signal is on the air, and simulcasting is the operative word here. As of April 1, 2005, the NTSC analog and DTV transmissions must be identical. The U.S. Congress mandated that the NTSC will continue to operate in those markets provided there's a couple of conditions existing. One is that one or more of the top 4 networks are not broadcasting in DTV in that particular marketplace, and there would have to be extenuating circumstances for them to continue to hold their license and be in that position. Or the D2A converters and block converters, which let the existing analog television system sets receive the signal, are unavailable. Or 15% or more of the TV households in the market area do not subscribe to a cable carrying system carrying the digital channels, or the population does not have the other converter equipment. The carriage rules. Some of the 70% of the U.S. households are serviced by cable, and the FCC has looked at the matter of forcing cable companies to carry the DTV signals. After all, if the cable companies decide that they don't want to invest the money in capital to have their plans capable of carrying digital, digital will fail. Ultimately, Congress won't get back the spectrum, and it's a no-win situation for Congress, which is looking for the money to help balance their budget. The proposed rulemaking in July is intended to address some of these issues. Does cable need to carry both analog and digital signals? What percentage of the system capacity must be used up to carry digital? Can the cable operator change the original signal format? Because there are fundamental issues here. The modulation system used on television over-the-air broadcast is 8 VSB. On DTH satellite, like DirecTV or EchoStar, it's QPSK. And for cable, it's 64-256 QAM. They're incompatible. So what are they doing here? Does high definition have to be down converted? And when does this all have to happen? If this process follows the channel allocation process that went on in the States for a couple of years, it'll take some time for a form of consensus to arrive. And then when that consensus arrives and somebody's not happy, the gentlemen known as litigators and lawyers will get into the middle of it, and it'll go on for a little longer. And then when must cable begin carrying DTV? The current rules state that cable systems with more than 12 channels must carry, but less than 36, must carry the local stations up to a maximum of a third of their capacity. For cable systems greater than 36 channels, they have to carry all the non-commercial stations and the commercial stations within 50 miles or in the grade B contour. Cable companies are also obligated to carry the whole signal, not part of the signal. Let's look what's happened with the rollout of DTV in the United States. In November, there were 24 stations on air. This increased to 43 in December. Thus, there was at least one station in each of the top 10 markets operating. The networks are transmitting a mixture of high definition and standard definition programming. The formats are mixed between progressive and interlaced. Some of the people are planning multi-channel standard television operation. Planning is the operative word. Some of the network plans in the U.S. This is a summary of the format plans of the U.S. networks, plus 2 of the leading DTH providers, EchoStar and DirecTV. Although we have a common ATSC transmission standard, that's where it sort of ends here. The good news here is there's only so many formats to choose from within the ATSC guidelines, and the converter boxes are all supposed to work to convert between multiple standards for the display. The following is a general outline of the approach of the 5 U.S. networks. I was talking to actually someone from each of the networks today, and both DirecTV and EchoStar. And nobody wanted to be quoted, but some of the things that are here may not be here because they're still trying to figure out how they're going to do things. But in general terms, this is what they want to do. ABC wants to be a progressive Disney ABC plan. Network to station distribution will be done using 720 progressive, and the initial distribution may well be by D5 machines, bicycling tapes around, like the old days of cable. They're sending 2 hours a week of Disney programming, plus another 2 hours a week on the Thursday night movie. So they're running 4 to 5 hours a week of programming. And their preference happens to be 480. CBS wants to use 1080i for their high definition. There's been some management changes at CBS, and I understand there's some things being reviewed at CBS. It's not going as quickly as it was before. There is no regularly scheduled programming running at this time. Fox has the only all-digital network plant running in the United States. Their preference is to use 480p 30 from the network to the stations. They drop in a 45 megabit compressed signal with 422 profiles. Stations are analog composite plants, but they run HD and they leave it in 270 SDI up to the translator, and that's where it stops for them. They believe very much that the combination of a digital signal and progressive scan gives the biggest bang for the buck for the consumer. Fox is not a big fan of 1080i. NBC is using 1080i for prime time, and it'll likely use 480p for their standard definition format. They plan to transmit 10 hours a week. They're converting the Tonight Show to a high definition for the spring of this year. We know that the 2000 Olympics will be component analog, and we know that 2002, wherever it happens, may have some high definition television in it. I do know from conversations with people for the last football game transmitted last weekend that the response to the high definition transmission was extremely good. So I suspect that we'll see high definition coming out of Salt Lake, assuming it's Salt Lake. Here is where we are today. As of December the 2nd of last year, 189 or 11.1% of the stations have applied to the FCC for DTV permits. They've granted 118. There's 10 held back for international boundary issues, 1 for Mexico and 9 for Canada. What's happening with the DTV broadcasters in the States? I had some real interesting conversations. Again, nobody wanted to be quoted. But generally speaking, this is sort of the themes that seem to be evident no matter where you go. A lot of blue sky thinking and what if happening went into the design process and pulling a plant together. They had a real problem getting equipment, which of course is a surprise. Everybody likes to use the 1.5 gig baseband plant, generally compressing to 45 megabits. There's a lot of money spent to get the plant up and running. But the DTV operation is not even on the radar screen of management. That's perhaps because there's no perceived financial return from it at this time. The attitude of his sales staff, one engineer told me today that based on the football game on the weekend, that one of the salespeople came to him and said, look, that looks really good, maybe I can try to sell some time on this. And that's the first positive response, he said, from anybody in the management side if you want to put sales and management together. There's no one allocated in any of the DTV stations to run the DTV station. They don't want to know about it, they have no time for it, they won't even hire anybody to run it. Engineering generally becomes the programming department, calling the local retailers, telling them what program is running, becoming the liaison between the people that are selling sets and the people who are putting the programming together, which is engineering department, which is not generally an engineering function. The programming material is very, very scarce. Programming rights are a big issue. One gentleman I talked to had a great program he wanted to run, but because they didn't have the rights, they couldn't run it. Local retail outlets are running promotions during HDTV broadcasts. The football game, a store in Houston, advertised that it would be open running DTV sets, and they had the place swamped with people watching the game because it looked great in HD. And I know when I was in Atlanta at the games, when we were in the Olympic Stadium, we were shooting the opening ceremonies, looking at it on an HDTV camera that they had in. It was interesting. As people walked in, you'd see a mass of heads on the NTSC cameras and screens. When you looked at it on HD, you could actually see the hats separately as opposed to being a merged conglomeration of mush, and you could read things on the hats. The other thing they found, which is interesting and was partially predicted, is that the power used to get an equivalent distance or coverage with a DTV signal requirement is less than for the conventional NTSC transmission. At the CES show in Los Angeles last week, or Lost Wages last week, there were 13,000 DTV sets apparently are in the supply chain. Less than half of those have been sold. But they said some $40 million had been spent on DTV sets. So I haven't done the math, but the sets are running around $5,300 US a set. Converter boxes are running about $1,500. But every TV manufacturer there was showing a widescreen high-definition set. At the CES show, HBO announced that it had put a deal together for distribution via EchoStar. EchoStar announced the HBO deal plus its HDD transmission philosophy, which is 1920 by 1080. DirecTV announced a deal with New Line Cinema to distribute high-definition programming beginning in May '99. New Line Cinema is a production house in the LA or Hollywood area which is solely dedicated to putting movie titles together on high definition and licensing those titles for distribution by traditional pay-per-view television. Some of the challenges. Intellectual property. Just as the RDAD got the attention of the recording industry, high-definition television has got the attention of the studios. Now the viewer can get a good, high-quality copy of a movie. And we now have distribution issues and copyright. They've lost control of the distribution of their products, and they're quite paranoid about it. A number of solutions have been proposed. One of the leading solutions is the IEEE 1394 standard. It gives HD a pass-through on the cable box. It's fast enough to handle multiple simultaneous video streams, including data streams for direct PC type connections, downloading software, which is one of the options that they want to use this data channel for. It's got the potential for using conditional access control, which could be applied to the downloading of software. It's got standardized copy protection scheme. And then there's the issue of the post-production standard. What are people going to use to do that? At the November SMPTE meeting in Hollywood, there was a group that got together that was pushing a 1080 progressive 24 frame by 1920 pixels as a post-production standard, optimized for film to video post-production. It eliminates a 3:2 pull-down, product gets finished in 24 progressive, and it's very, very easily converted to 24, 30, or 60. And for international distribution, and Fox, for example, is a company that makes a lot of its money selling internationally, it converts to 50 very comfortably. And then we have the FCC proceedings, 98-203. And this asks for the following comments on the following idea, which is going to scare the pants off the conventional broadcasters. PBS stations can offer ancillary supplementary services, including subscription TV for money. And this is not the way PBS originally went together. Also, the ban will be lifted on advertising on the subscription services they provide. The notice also states that the FCC is looking to establish programming to assess and collect fees from commercial broadcasters when they use the ancillary and the supplementary uses of the spectrum. This is something new again. Again, it's the FCC and the government is clearly looking at the financial opportunity that this is presenting to them. The ancillary services include subscription services, computer software distribution, data transmissions, teletext, interactive services, and audio signals distribution. When this is all done, they're going to repack the channels, and they want to reorganize the spectrum after the end of the NTSC transmissions. The FCC wants to reclaim that spectrum, and so they repack it. Then they will allocate this freed up spectrum to new users and sell it and auction it off. And who can forget about the money that the government picked up in the US when they sold off pager, cellular, and orbital spot locations. That's all I have to say. I hope I was clear. Thank you.
Thank you, Stephen, for bringing us up to date on what's happening in the U.S. Do we have any questions for Stephen? There's a microphone here for anybody who has a question. We have an opportunity also to ask a question at the end of the presentations. No immediate questions? Thank you again, Stephen, very much. Canadian Governor Edward Holmes will present Stephen with a token of our appreciation following the televised portion of the show. Thanks again. Now, beginning with Carol Darling, we're going to turn our attention on Canada and the Canadian situation. Carol is Vice President, Engineering and Affiliate Relations at WTN. She is a professional engineer with over 18 years of experience that includes both hands-on engineering and strategic business planning within the communications industry. Carol is currently chair of the Canadian Digital Television, Inc., CDTV, Technical Working Group. She has been involved in digital television development for over 10 years, with previous appointments which have included the chair of the Advanced Broadcasting Systems of Canada, or ABSOC, we all know about, remember, fondly, co-chair of the joint ABSOC-JTCAB Television Committee, Canadian industry representative on the U.S. Advisory Committee Technical Subgroup, which oversaw the definition of the Grand Alliance DTV system, membership on the U.S. Advanced Television Systems Committee, or ATSC, the Executive Committee, and membership on the Ministers' Task Force on the implementation of digital television. Before launching WTN, her previous positions included Program Director of ABSOC, Director of Business Development and Communications Consultant at Nordicity Group Consulting Limited, and several positions involving engineering, economic, and regulatory assessments and marketing at Bell Canada. At the Women's Television Network, she has day-to-day engineering and operations, and she's also responsible for relations with WTN's cable and other distribution affiliates across Canada. Carol's very much involved in DTV development in Canada. Please join me in welcoming Carol Darling. Carol?
I was given the easy task tonight to try and set the scene for our discussion for the work that we see ahead of us here in Canada. And I was going to start by trying to address the question, why the heck do we need to do anything anyway. But I think in Steve's presentation, he very nicely answered that question for me. You know, for those of us in the technical community, if we did follow the US model, when do we get the chance to play with great toys, not have to worry if our colleagues in management are watching to see if anything's really working or not, and get to program too? So seriously, I'm going to take a crack at answering that question. Also, review for you the foundation that was laid for us in our work in the task force and the recommendations that were put forward to the Minister of Heritage a year ago last fall, and then get to my real job, talk to you about a newly formed Canadian industry organization, Canadian Digital Television Inc., or CDTV, and take you through where we're currently at, who we are, and the work we see ahead of us. David touched on some of these issues in his opening remarks, but you know, my work over the past few years within ABSOC and within the task force, whenever we got together to try and address what we needed to do, the very first questions always were, why do we need to do anything anyway? And why don't we just do whatever they do in the United States? And after some discussion, we'd always come to the same conclusion: small market, big country. Our population's close to the border. All these things we know very well. We live with U.S. services competing with our own. In fact, they're highly integrated into our own system. Because of our market size, our regulatory system has developed as a tangled web. Each sector of the industry supports the next, and we all love doing that, of course. But even aside from our regulatory system and the business world that we live in, even on the distribution side, a really good example of how we're different than the United States. The over-the-air broadcasters were charging out and implementing over-the-air digital television in very large urban markets where they weren't initially concerned that their signals wouldn't be carried over cable. Their penetration is 70%. Ours in Canada is much higher, 80% in our urban centers, even higher than that. So certainly, none of us in our discussion, those in the over-the-air broadcast community, could contemplate a scenario where we charged out implementing DTV without including our distribution undertakings. Now, we also know that if the DTV entry in the States is successful, it will affect us. I can't answer for you how much, or more to the point, how fast, how soon. Certainly, as Steve talked through some of the early initiatives we're seeing, for any of you that may have attended the CES show last week, the consumer electronics industry gurus are predicting a very successful year in terms of their new products, predicting products may go off the shelves to the tune of 6 figures across the U.S. Their very early experience is proving that the market that's taking these first sets is not the market they expected. It's not the typical early adopter, but those who view a lot of television and want the good toys. So it'll be very interesting to see what happens. And certainly we're starting to see some very early initiatives from the U.S. networks, and we have yet to see how things will fare. We do know that history has shown us that if we don't get our act together, our own very loyal viewers like to disconnect from our system. We've seen it with color television, and certainly we've seen it in the direct-to-home market. So a few years ago, some key leaders in the industry got together and said, we need to do some homework. We can't sit around and wait for these things to come at us. We better get prepared and do some thinking. We need a coordinated plan, and we need to work together to do that. It's going to take us a lot of work and a lot of time. And very wisely, knowing this, our Minister of Heritage struck a task force of executives from all sectors of the broadcast industry, television industry in Canada in the fall of 1995. And I have to tell you, it did take us a lot of work, and it did take us a lot of time, but in the fall of '97, we came up with 17 recommendations that we put forward to the Minister of Heritage. 3 of those recommendations have been adopted to date. First of all, Industry Canada has adopted the FCC approved standard for over-the-air broadcast, the Advanced Television Systems Committee A53 standard. They have also gazetted the over-the-air allotment plan for Canada. And thirdly, what I'm here to talk to you about is a new organization that was created, Canadian Digital Television Inc., over the last 10 months. An industry organization, not-for-profit, set up to help guide us through this transition. Before I get into CDTV, we thought it would be useful to review the recommendations that Task Force made, because these will form the foundation of some of the work we see ahead of us. First thing I should say is when these recommendations were put forward, the notion was presented that these were flexible recommendations, things in terms of time frames and the benchmarks that we laid out. We knew that we were going to have to monitor carefully based on what we see happening south of our border. So don't panic when you see some of these dates. We know we have some work to do to adjust them as need be as time goes on. In the fall of 1999 in Canada, the notion was that we would have up and running digital television broadcasting in Montreal, Toronto, and Vancouver. I hope that slips a few months. Some 5 years later, just tracking slightly behind the United States, over-the-air broadcasters should be compelled to implement a digital television license. As well, specialty and premium television should be required to implement. And our broadcast distribution undertakings, cable, direct-to-home, MMDS, not only should be fully digital capable, but capable of carrying these signals. Clearly a huge challenge in this time frame. And similar to the United States, over-the-air analog broadcast should cease a year behind the US in the year 2007. This provision was laid out to be reviewed as we get further into the process. Just a note, the notion was here that we would benefit from lagging slightly behind the US by about 18 months. And, but it was dangerous for us to think of lagging too much farther because we'd have some very unhappy consumers if things truly take off in the United States. We didn't deal with the complex issue of formats, thank goodness, but we certainly did try and set some benchmarks in terms of where we were aiming in terms of picture quality. The statement we made was that digital television must be clearly superior to existing analog transmission, dealing with the issue of that all our broadcast at that time should be in the 16:9 aspect ratio, in a resolution at least as good as existing 525 line analog television. And by the year 2007, when NTSC transmitters would notionally be shut off, 2/3 of each broadcaster's schedule should be in HDTV, and 2/3 of Canadian content should be in HDTV format. We have a little bit of work here too. When broadcasters make their signal available in DTV format, the notion was that our broadcast distribution undertakings should be required to carry it at the quality that it was initiated. At the time we did our recommendations, some of our government participants were very concerned that we needed to take an active role and bring together some of the different products that we saw discussed in the marketplace, that we'd be in a position where our consumers would be very confused. I'm very pleased to see that over the last year or two, there's been some great progress made in this area in the United States, and hopefully our work in this area will be done for us. We're certainly tracking it very closely. A few notes in terms of over-the-air broadcast. In terms of the recommendations, all over-the-air broadcasters should be granted a digital license. This should not preclude new licensing of stations. The allotment plan should be issued with a whole bunch of wonderful qualifications of what that allotment plan should do for us, and that has been done, or at least gazetted. Related to the issue of how broadcasters could use their spectrum, no worries here. Certainly we have, in terms of process, we have both the Broadcasting Act in place that could deal with the issue of auxiliary broadcasting data, and should a broadcaster decide to get in the business of some other services, those initiatives would be covered under our existing Telecommunications Act. Analog and digital simulcast should occur, recommending that over-the-air broadcasters should be allowed at least 14 hours a week where they could substitute alternate content to try and foster development of new unique programs. Free and universally available TV must continue, and where technology allowed, our existing rules and regulations should be kept intact. Things like priority carriage, program substitution, which we know presents some technical challenges for us that need to be thought through and access. The requirement for a single station to own their transmitter should be removed so that the opportunity to share transmitters in Canada would be allowed. On the production front, we also provided some good recommendations. Just touching on them, the government was encouraged to support existing programs. Certainly the Canadian Television and Cable Production Fund should be continued at its current level of funding from current sources. And of course, we need more money to do all the work that's ahead of us, and we requested $50 million from the government to supplement that fund to help us kickstart our production industry and getting into these new formats. And finally, next subject at hand, a new organization should be created, drawing together all of the players in the industry to help us manage this transition ahead of us. So that was done. Canadian Digital Television has been created to guide an orderly migration to advanced television services and help us work through a lot of difficult questions at hand. The plan is that we will be directing some research and testing, continuing to advise government on policy, regulation, and taking the initial task force recommendations further down the road, and develop and monitor the plan that was notionally laid out in our recommendations, and really dig into it and help us in our own businesses get on with it. Significant membership, and I know you probably can't see that on your monitor, but let me tell you that broadcasters have joined CDTV in full force. Specialty and premium services are represented, the cable industry, our satellite service provider, Telesat Canada, and Users Association, the CSUA, Canadian Film Board, and equipment suppliers, both professional and consumer electronics equipment suppliers, are members, and the list is growing. In terms of our structure, I'll try and explain these boxes for you that probably look like blobs on your set. Board of Directors with 4 working groups struck to assist and guide the board in their work. Technical Working Group, Communications Policy and Regulation, Economics and Marketing, and Production and Training. And the bottom blobs at the bottom of your screen are subgroups, which it's not quite as bureaucratic as it looks. Certainly in the technical working group, we'll be creating those subcommittees to address particular issues on a as required basis. In case you just think we picked up a bunch of riffraff to form a board of directors, not the case. Our board of directors is led, chaired by Jim Sward, president of CanWest Global, and a very esteemed membership. A couple of faces that you probably recognize from your SMPTE meetings: Chris Bell from the Movie Network and Pat Whittingham from Sony of Canada. Just to leap into the work of the working groups and try and give you a bit of a status report of what's up to date. The Economic and Marketing Working Group has been struck, chaired by Grant Buchanan of WIC. The vice chair is Pat Whittingham from Sony. 2 subcommittees have been struck, the first chaired by Henry Eaton from Baton Broadcasting. Its easy task will be to work at identifying the economic implications and capital requirements for each sector of the industry, and create economic models from which some serious business decisions can be made. As part of that, various scenarios will be looked at, and certainly in our work in the technical working group, we're hoping to provide some background work to support that work. Another little task to continue to provide advice on the timing questions for the commencement and completion of this transition. The marketing subcommittee is chaired by Robert Gumila from Toshiba. Their job was really to develop a marketing strategy for an industry rollout. It was felt that there would be some advantage in having a coordinated story which we can present to our Canadian viewers and consumers. First job that's being undertaken right now is a pamphlet is being prepared to try and explain the DTV initiative and products entering the marketplace to assist consumers understand this thing, and I suspect to assist some of the those people in the retail outlets who are probably being bombarded with questions right now. Pamphlet's underway, soon to be available. The notion is that it could be rolled out to the receiver retail outlets. Future public demonstrations planned and possible market research as may arise, as the need may arise. Policy and regulation. First task at hand, which Michael McEwen, the president of CDTV, has undertaken, is try to get our ministers to respond to the recommendations which were made. Our government was waiting for the industry organization to be struck and get up and running, and we're there now, and anxiously awaiting for some wise guidance from our minister, and that's first on the plate for this working group. Following the policy recommendations which come forward, there will be lots of regulatory work to follow up on furthering the task force work. The production and training front, certainly if you get a hold of the task force report, there's some very good thinking laid out in terms of the kinds of programs that could be put in place to assist the production community. This work will commence hopefully when we get some news back from our minister, and lots of work to do here. I'm not that close to this work, but I certainly can tell you a little bit more about the work we're doing in the technical working group, because as luck would have it, I chair this group. Very honored to be doing this, but the best news for me is that I have some great help to do this work. Two vice chairs, Wayne Stacey from Stacey Lawson and Associates, will be heading up our work in the terrestrial transmitter front, and Lou Montana from Montana Engineering will be providing support for us in terms of general technical issues. In fact, we commissioned Lou in the fall to try and help us work through development of a work plan. When we first started out with our working group, we had this long shopping list of 1 million technical issues that everybody needed to get their heads wrapped around, and we had to really sort through these issues, take a very close look at what was going on in the States, and Lou did some legwork talking to U.S. networks and some of the key players there to help identify the hot issues that we felt we needed to understand better in order to provide good advice as we go along. And based on that work, we were able to get our heads wrapped around our task at hand and have drafted up the following objective for our working group. Our job really is, first of all, is to provide support to our board and other working groups on technical issues. We really want to focus on providing answers to technical issues which will have direct influence into the business directions that are taken and the business questions at hand. We're certainly not looking at technical issues as a make-work exercise, and we have to be very closely tied into the work they're doing in the other working groups and supporting the work they're doing. What we plan on doing is gathering together the information we learned from our U.S. participation, some Canadian tests and trials, to assist with implementation in Canada. We're going to do this through 5 different initiatives: monitor and participate in the key U.S. activities, oversee and coordinate some particular tests and trials, look at a few of those technical issues which we believe we need to understand better to provide some guidance and input on some of the implementation issues that need to be dealt with. And we need to undertake a little education program to get ourselves up to speed on some of these things, and certainly distribute some information. I'll just dig a little bit deeper into our work plan here to give you a bit of flavor for it. In terms of monitoring, over the past few years, ABSOC has supported representation in the Advanced Television Systems Committee, the ATSC. I've had the pleasure of representing Canadian industry on the executive committee. We have a much coveted position there, and actually are able to vote in some of the key standards and implementation directions that are being taken. The ATSC is not just a North American organization. In fact, it's opened up its membership internationally, so some very interesting discussion takes place there. Certainly now, the discussion is turning from issues of strictly standards development to key issues related to implementation, and it's very interesting to see some of these issues being sorted out between the consumer electronics industry and the broadcasters sitting around the table. So we plan on continuing that representation. Our ABSOC's membership, now that CDTV has taken form, our membership has been transferred to CDTV, so we certainly will continue to provide this continuity in our representation. We'll also be taking a close look at the work going on in the Society of Cable and Telecommunications Engineers and the Electronics Industry Association that's doing some work of some of the issues that are really important for us to understand. 3 possible test projects have been identified to date that we think we'd like to focus on. Certainly the first one, the test transmitter project, is at this moment getting underway. The first phase of this exercise will be some propagation tests with the objective to test the underlying assumptions behind the allotment plan. To this point, the plan looks terrific on paper. Some of the assumptions are slightly different than those that were made in the development of the plan for the U.S., so we'd feel a little better if we could test those in the real world. Would also hope to provide some plant assembly experience, which we could pass along to the rest of the industry, and also provide a facility for some demonstration. A preliminary off-air test is planned at this moment for Mount Royal in Montreal, with CBC taking a lead in that exercise. The extended testing program will take place from Manotick, the Ottawa transmitter site. This site was picked for a number of reasons. Our Communications Research Center, government participants are located close by and will be able to provide a lot of assistance in this work. As well, CBC, Global, Bayton, Chum, and I may have missed somebody, all located out at that transmitter site. As well, Rogers has some fiber that connects very close to these facilities, which we may be able to take advantage of. Right now, we're also considering possible sequence to conduct some further tests and hopefully use this facility to its best advantage. Right now, we're in the process of collecting some contributions in terms of equipment. We've had some proposals for loan for equipment from some transmitter manufacturers, and we're certainly trying to gather all the pieces of in-kind contributions that we can. So if you have some, please don't hesitate to step forward. Second project that was identified was brought forward by Telesat Canada. They would like to take a lead role in taking a look at some format and bit rate issues and giving us some hands-on experience of our own to understand some of these issues, particularly as they may relate to consumer display. Their intention is that we might use this in our collaborative forum to provide some guidelines for satellite transmission in Canada. And we also think that this might be important work to help us understand some of the bit rate, format issue, trade-offs, capacity questions for our distribution systems. There's a lot for us to learn here, and we're hoping that the results of this work will feed into the scenarios that will be considered in the economic subcommittee work. We're currently about to charge off, hopefully, and develop the scope of this work, hoping for a spring '99 start. The third project, which is, I think, notionally been laid out at this point, is at some point it may be advantageous for us to look at a joint master control test facility. This might allow us in a collaborative forum to look at some operational issues, allow some research, familiarize us with some of the equipment, tours, etc. Obviously, once again, we'd be looking for some equipment, supplier equipment contributions, and if you have some, let us know. and also a member company to host this facility. And I see this project not being kind of first on our list of priorities, but it's out there, and we'll be taking a look at it as time goes on. Now, certainly all of our work is to provide guidance and input on implementation issues, but we earmarked a few key areas where we felt that we really needed to understand better in order to provide some wise guidance for some of the business issues that need to be dealt with. The first, operational issues from end-to-end transmission of DTV across all distribution mediums. Huge challenge, lots to learn here, and a lot to be benefited from exchanging information in this joint forum with all the players around the table. There's also some issues that we'll have facing us when we get to receiving U.S. signals in various formats from the United States at network facilities, and there's some issues there we need to understand better. Hopefully there'll be just some wonderful conversion products which will make all this easy for us, but we need to dig in there a little bit. Certainly there's some work in other areas that we've earmarked. You'll see some of the list here. I'm not going to get into them too deeply. I'm going to let Lou Montana, who's following my presentation, get into the guts of some of the technical issues that we've identified to date. But you'll see our short list here, some of the things that are first on our plate identified. We certainly need to educate ourselves first within our working group, and are planning to put some tutorials together to gather some expertise where we can and address the critical subject areas. But we don't plan on keeping this information to ourselves. We're hoping to distribute this information through a number of ways to the industry at large. Certainly we'll be providing regular input to our board and other working groups. We'll also have a CDTV newsletter, which should be launched, I think, within the next few weeks, which should be available to you. CDTV is also planning on putting up a website. Some of us will also be writing some articles in magazines. I have the opportunity to write a column on occasion in Broadcaster magazine, and I'm hoping to be able to use that forum to let you know what we're up to in our technical working group. We plan on doing some special reports on some of our key trials and activities that we undertake. Geez, I should have told you this first. Don't get too excited yet. This work plan I've just presented for the technical working group is still a draft. In fact, it's hot off the press. It's a work in progress, I guess, at this point. We're planning on presenting it to our board of directors in early February, so it could be refined somewhat. But clearly, we know we have a lot of work to do, and I'd just like to close by saying to you, if you're all excited about getting involved after my talk tonight, I encourage you to contact Michael McEwen at the CDTV office in Ottawa. If your company is not on the list of members, we'd love to have you. I expect to be doing some great work and could benefit from your contribution. And on a note from the technical working group, if you're dying to participate in some of our tests and trials and happen to have some great equipment to loan, or especially an encoder tucked away in a closet somewhere, please call me. Thanks very much.
Thank you, Carl. Thank you very much, Carl. Do we have any questions for Carl before? One question here.
Mark Walewski, Global TV. Very simple one. Do we really need Canadian testing? Like, the testing was done in the States, I guess we can get the data. Why we need Canadian testing?
We're metric.
That's true. That's true. You know, actually, we've asked that question. Before this program was put together, and the feeling was that much of the testing in the United States, the people in the States benefited from things they were testing. There was a feeling that we would really benefit from some hands-on experience ourselves. And some of the assumptions that went into our allotment planning exercise are different in the United States, particularly the coverage areas. Some of the interference parameters with NTSC are a little bit different, and we want to make really sure that in a real-world environment that they work.
So you believe that we need this testing? Like,
They have
you know,
me
If
convinced.
we go from one city to another, it will be different. So if we
Yeah.
test something in Montreal, we go to Vancouver, it will be completely different. So, you know, like from States to Canada.
Certainly, I think the over-the-air broadcasters who have dug into this pretty deeply are pretty convinced that there'd be great value in the testing.
Thank you.
Any other questions for Carl at this point? If not, thank you again, Carl,
Thanks
very
very
much.
much.
Edward Holmes will have a certificate of our appreciation for Carl at the end of the show. Thank you. Our next presenter is Lou Montana. Lou is going to help us continue with our exploration of the Canadian Challenge. He'll address the technical approach to the provision of DTV in Canada. Lou graduated in 1979 from the University of Waterloo with a degree in electrical engineering. He started his career, actually with me, at Imagineering Limited, where he was involved in numerous facility design projects, one of which was Canada's first high-definition television mobile. He later spent 2 years with TV Ontario's engineering group and was involved in a number of projects there. In 1992, Lou formed Montana Engineering, Inc., a facility design company whose most notable project was the TSN Broadcast Centre, the second digital broadcast facility in Canada after the CBC. In 1994, he joined Netstar Communications, at that time known as Labatt Communications, as their Vice President of Engineering, where he was responsible for capital projects and technology planning. In the spring of 1998, he returned to operate Montana Engineering and is now supplying services in facility and system design as well as in project management. Some of their current projects include the Sheridan College Center for Animation and Emerging Technologies and a master control facility for Treehouse Television. Lou also serves, as Carl pointed out, as Vice Chair to the Technology Working Group of CDTV, where he has provided technical support and assists in the development of their work plan. Lou is a longtime member of the SMPTE and a registered professional engineer in Ontario. Please join me in welcoming Lou Montana. Lou?
Thank you, David. And good evening, one and all, here and abroad. Certainly a pleasure to address you once again. I know the slides are very hard to read. That's the NTSC that we're having to live with there. And I didn't realize that we were going to be in this mode when I did this presentation. So if anyone would like copies of these slides, just let me know after and we'll send it along. I don't have too much that's hard to read. A couple that will be. The title of my presentation is I Want My DTV, and that should have an H in front of it, but I can't find it. It started out as a working title, but I couldn't think of anything better, so it's stuck. I didn't have mic before? Okay, because I just got a little bit of feedback there. So where can we find it? And that's what I'm here to sort of help us search for. There we go, the map to DTV. This would be hard to read even on a large screen. This is actually a map that was created by the ATSC Implementation Subcommittee. It is available in last month's journal. But I thought I'd throw it up there just for fun. It is sort of lays out every possible scenario for a broadcast plant up to an over-the-air transmitter. And the entire report in the journal, I highly recommend. It's a very good read. It's not a very hard read, but it's put together by over 70 participants, very expert in their field. It goes through much of what I'm going to talk about on the origination side. So I thank them for the use of their slide, and I know you can't read this, but there's a lot of work to do and many issues to deal with, and there are going to be many twists and turns and diversions along the way that could be costly and, more importantly, bog things down to the point where we get far behind the Americans. Both the over-the-air broadcasters would get behind. And more importantly, we have, I think Steve mentioned the direct-to-home implementations by DirecTV and EchoStar. These services are going to perhaps leapfrog what the over-the-air broadcasters are doing in the U.S. because they don't have the restrictions of the infrastructure that the over-the-air broadcasters have. So although things may seem to be moving slow from the over-the-air broadcaster side, there is, I think, a danger of an acceleration that we may be surprised with. But on the other hand, I don't want to give you the sense that these are matters of urgent nature. There are going to be lots to deal with. In Canada, it's not mandated that we move to digital television. So things are going to move a little slow from that standpoint. But in that time, we can use it to sort out what it is we have to do. Here's a much simpler drawing, and again, I don't think you can read that, but it's just 3 simple blocks: origination, transmission, receiver, and display in one block. And I'm going to talk about the issues within these 3 boxes. And what is an issue in one may not be a problem in the other, and vice versa. One block I didn't draw is contribution, which is I know a big issue for networks, but that's sort of in the transmission block, and I just wanted to keep things simple for tonight. But those are the 3 main areas. So that's my simple map. And some of the factors that have created the issues that I'm going to talk about are, and Stephen has touched on these, are signal flexibility. One of the strengths of the ATSC standard, as Steve pointed out, is that it's immensely flexible. You can use it for 4 standard definition channels, or 1 high definition, or 1 so-so high definition and a couple of standard definition. So it's incredibly flexible. And the ATSC couldn't get its members to agree on the 1 format. That's why we ended up with a family of formats and leave it up to the market to decide what to use. So that signal flexibility is the biggest factor that leads to the issues that we have. Complexity. These are complex systems we're talking about. The digital compression systems, the control and setup of those are intensely complex, and there's a lot to be learned there, and you'll see more as we go along. Bandwidth, not an issue for over the air, but for cable and satellite, big issue. And existing infrastructure. You know, we're stuck with NTSC. And a statistic that I heard at the SMPTE show, the SMPTE conference in November, that there's maybe 10% of the broadcasters in the US are digital, component standard. I mean, there's over 90% that are still NTSC analog. And that's a big hurdle. And just to make that conversion. Fortunately, in Canada, I think some of the, CBC, TSN, Discovery that I was involved with, and some others have made that leap already to digital, because that's your first step, is to convert at least to 601 digital. And the business side. I'm not going to talk about that, but you can drink a few jugs of beer just talking about the business, the marketing aspects of, is it going to take off? Is the consumer going to buy or not? And that's and how does the broadcaster make money? I'm not going to deal with that right now. Stephen showed you this table earlier. I don't know if you can read it, but some of the numbers are pertinent. At least the first 2 lines. Let's see if I can get the mouse to work. The first 2 rows here represent high definition formats, the 1080i and the 720p. The lower 2 are not considered high definition. They're standard definition in the terms of the FCC. This line here represents component 601 plants of today, the CBCs and TSNs and others. So that's it in a sort of encapsulated table, and we'll refer back to this. And one of the things I want to point out here is the horizontal pixels, the 1920 and this 1280 here, the 704, because it's, oops, is this on a time, Steve? Page, okay. It's significant in that you can play around with these pixel rates here. Keep the lines the same, but reduce the number of pixels and reduce your bandwidth. And that's what DirecTV is doing. And it's not a standard. Doesn't fall within the family of standards, but heck, they got a pretty nice picture out of it. And they can squeeze it on, I think, 2 on one transponder, right? So, and they're marketing their service with a Thompson box, and they're going to start making it happen. They're not constrained by this. Another direct-to-home broadcaster, Unity Motion, same thing, closed-loop system. They've picked their own set of parameters from here. They're commissioning the box and the display. You can buy that for $7,000, a monthly subscription of $50 a month or something like that. And they've picked their own format. They're not constrained by this. So, the over-the-air broadcaster may not be the timing driver in the US or even in North America. And these formats cross into all the 3 boxes I showed you at the beginning. They play a part in each of those 3 boxes. And you can use one format in one of the boxes and another format in the middle box. The set has to receive it all. It can't go dark. So that's one of the rules of the ATSC. The receiver display, in order to be an ATSC compliant receiver, must decode all of these parameters, all of these configurations. They don't have to decode the DirecTV style signal, but DirecTV has commissioned their own receiver to do that. There is no consensus, as Steve pointed out, in what's being used. And as he mentioned, he is looking at a production standard of 1080p 24 frames. And there's a big push for that format. There was a big meeting at the Western Cable Show, and I think SMPTE has set up a working group, and they're really pushing hard, this group, for this standard to become the production standard. And it doesn't appear on here. Or sorry, maybe it does. Yes, it does. But that's what they're pushing for, is for the progressive standard. Okay, page down. Okay, back to this map, just to show you again how that I'm going to deal with each of these 3 areas. Origination. What format are you going to use in the plant? Which of those, it works out to be 18, which of those to use in a plant? Are you going to distribute within the plant compressed or uncompressed if you're going to do high definition? Because there are proponents that say you compress that signal and you can route it through a standard definition 601 plant. It means a lot of compression, encoders and decoders in the plant. But it seems that most of the broadcasters in the US are building full bandwidth mini master controls. I haven't heard of anyone trying to implement a compressed master control. Not that there's, I don't think there is a master control switcher that deals with MPEG streams. I could be wrong there. There is a couple of PBS stations that are taking the compressed bit stream down from Washington and dumping it into a server and just streaming that out. So they never decompress. They always keep the ATSC bit stream. So that's one form. But that's an issue within the plant and I have a slide that illustrates that a bit more. Dolby AC3 audio, that's 6 channels of audio. If you're bringing in a network feed, you decode it within your plant, you have 6 channels of audio. What do you do with it? If you've done if you have an analog plant, you're SOL. Digital, Dolby and Envision are working on encoding systems to get the 6-channel stream into an AES pair. Means you need encoders, decoders, but at least there's a way to get it through the pipe. With a lot of this stuff being digital, there's metadata to consider. Routing these data about the data through the plant. Dolby AC3 audio has a number of parameters that have to be transmitted with it and that are set when you produce the content. And you have that metadata has to follow the audio. Otherwise, your Dolby AC3 encoder doesn't know what to send to the receiver, and the receiver at home doesn't know what to do with it. Some of the parameters are dial norm and DIN range. These are you can set the normal audio level and the dynamic range that the viewer hears at home. So this information has to go along with the audio data. And of course, you want to keep the audio and video in sync. And when you're doing, when you're dealing with compression, encoding, decoding, up conversion, down conversion, you're going to have to deal with keeping audio and video in sync. A couple more origination issues. And I'm staying away a little bit from production, except for this other bullet, because production is a whole other talk. And this top-down report doesn't really deal with production because they recognize it was just too much to cover. But you have to deal with this one in origination, and you'll have to deal with this one as in production, especially when you're dealing with trying to do a production that you want to transmit on your 4x3 service and on your 16x9 service. How do you frame the shot? Latency, the time it takes for the signal to pass through the plant, and the time it takes for a device to reset if you're telling it that I want to go from standard definition to high definition at the top of the clock. These devices do not switch like a routing switcher. They take a considerable amount of time to reconfigure. Those of you who have run compression now over the satellite understand that to do this can take matters of minutes. Control as well. There are many more factors to control. And data, I'll have a slide to illustrate what I mean by the data here. This is just a slide from the top-down report that I thought would summarize nicely the challenge for the origination center here. What do you do in the plant? What format do you settle on? And one of the recommendations, or at least what they believe would be a good suggestion, is the plant decides on what its format's going to be in the house, and they call it plant native format. That's their term. And it illustrates what can happen that if you're an affiliate, and digital television, another quote from the SMPTE conference, is an affiliate issue. It's not a network issue because the licenses be given to the affiliate. Affiliate has to deal with this. And the networks have all taken different decisions on what format to use, as Steve pointed out. So the affiliate has to say, well, what am I going to do? Many of them have chosen to be 601, serial digital, and they've built, they've called it a side chain, is the term I've used, a side chain for high definition. But they tend to use the bulk of their stuff in serial digital and then upconvert. Now, in the emission, which is on the right side of the slide, you can pick another standard. What do you think is going to be most efficient for bandwidth? What are consumers, receivers, or displays going to look the best? And there are some other factors, but you can separate what you use in the plant with what you finally emit over the air. And that's important when we talk later about cable, This keeps jumping on me. When we talk about cable and satellite, because what you pick here and the number of pixels you pick affects the bandwidth and in turn affects cable and satellite. Data I talked about earlier. You probably can't read this, but there's a lot of, there are two things about ATSC. You can transmit a whole lot of data that can either be about the program or not about the program. You have to get that into the encoder. You also have to get things like program service information tables, the PIDs that identify your service, because with all this digital stuff, the decoder doesn't know who you are until you tell it what it is. And that, by the way, this slide's also in here. And that data you have to be able to carry around the plant. So now you can see things like, where's the mouse? Can you see the mouse at least, the cursor when I? There's a data server here that's going to house that. It's going to have to extract data from the NTSC plant. This could be closed captioning, VChip data, and you may from over here from your wide area network bring in, I don't know, commercial content, ad enhancement things. I've heard about selling coupons and all kinds of things. So the data is going to be a big part of this. Now, you don't have to deal with this day one, and I'll talk some more about that later. So I don't want you to think that all of this you have to bite off at the beginning. This report, what it tried to do was cover everything, and then you sort of pick the path that you want to take as you evolve. And one of the points I'm going to make at the end is, you don't have to try to bite it off all at once. Start simple and learn as you go along. Control, and this again was a slide from the top-down report. There are some. These are the control elements. They divided it up. You can't see this. Input manager, baseband manager, and emission manager. This was to identify, and this is why engineers are running it, by the way, because only they understand this right now. But there are many more devices and configurations and parameters you have to set that are new. Wow, this keeps jumping on me. Sorry about that. That are new from the plant we're used to today. Over here, the emission manager has to set up things like video and audio encoders, PID mapping, PSIP generators, multiplexers, data servers, and MPEG editing. Baseband manager has to deal with format converters. By the way, these things are not new to the direct-to-home broadcasters who have had to deal with encoding and all of these things, because direct-to-home can't work without this without the control of these parameters. So they're far ahead and cable, I should say. So cable, some digital cable system in the U.S. are far ahead of what over-the-air broadcasters will have to deal with when they grow their services. Okay, transmission, and I put in brackets including contribution, because I don't want you to get a sense that I overlooked that. How am I doing for time, Dave? Okay. And I've divided up into three: over-the-air, cable, and satellite. And I'll talk about each separately. I'll get my paper in sync here with my slides. Okay. And as has been described earlier, the ATSC standard, very flexible, allows multiple standard definition or single high definition, and some parts in between. And Steve's gone over all the parameters of the A53 standard, so I won't repeat them. And as I've mentioned, cable and satellite can tweak it a little bit. That over-the-air broadcasters can't do. So here's my simplified version of the transmission map. On the left side, you see the over-the-air broadcaster, and my little doodle as a tower. I don't know if anyone has a tower like that anymore. The old one on Jarvis Street, I think. Oops. Specialty and specialty. Okay, now we can't forget specialty. They're used to be dear to my heart, but they and still are. At some point, they would like to be able to deal with high definition signals. They're already digital, by the way, most of them. So digital television is here, but it's not. I mean, they're not up to the full capability that it can handle. So I think the rest is sort of self-explanatory. Here's the pipeline that it all started out as. You know, like the over-the-air broadcasters beaming right to the home. That's where it all started. Over-the-air broadcasters said, "Look, we gotta combat these two guys over here. Let's come up with something they don't have." And that's digital. Oh man, I'm doing something wrong here when I move the mouse. Let's have HD TV. We can get it to the home. But someone forgot to account for the fact that there's almost 70% cabled homes, and then DirecTV came on the market. So there's been a lot of catching up to do to make this to bring these two together. And I think you can see where some of the problems occur here. That an over-the-air broadcaster has to get their digital signal through the cable system and through the direct-to-home service. How are they going to do that when cable is a different modulation scheme and has limited bandwidth? Direct-to-home, the same thing applies. And here's also where I wanted to talk about commonality. One of the things we talked about in earlier meetings is, does it make sense in Canada for all of these players, over the air and specialty, to choose a common emission format? In the US, all the networks have done their own thing. I think David has spoken about here in Canada that we have an opportunity more for cooperation. Carol alluded to it. Because it would make life a lot simpler for cable and direct-to-home. If everyone was, and where it would make it simpler, and things like program substitution, ad insertion, although they still have to deal with the US signals, have no control over that. But one of the things we talked about in the working group is, can we do something, can we reap some benefit by going to a common emission format to help cable and direct-to-home, both with the operational and routing distribution issues, as well as the bandwidth issues that they face. And the bandwidth side of things, I'll talk about a bit more. Okay. Transmission issues, I've touched on some of these. Bandwidth, I mean, the direct-to-homes and cables, they're fighting for their lives to get bandwidth happening. And a point that was made at one of our recent meetings is that some of these new displays, although they're HD, because of their construction, cannot display more than 700 lines anyway, because the shadow mass within the sets. Now, that's going to get better, but there's been some discussion behind closed doors, not here in Canada, but in the US, our doors were open, that we would, that the broadcasters and everyone might go to a lower horizontal pixel rate to facilitate a lower bandwidth, which is all the sets can display anyway, and maybe that would help cable out. So that's something that the industry here in Canada, I think, should explore. Signal format is there any benefit for us to to use the same signal format within the plant? It just might make the economics of volume purchases a bit better, but it's more, I think, more important on the emission side. But this is something we want to analyze a bit more in the technical working group. Just is it a benefit or isn't, or is it a non-issue? So antenna sites. I think Doug Bonar said it at one of our meetings. I mean, the first thing you got to do is find a place to put your antenna. This is for the over-the-air broadcasters. In the U.S., it's been a huge challenge finding space, structural upgrades to towers. And I don't think they can fit any more antennas in the CN Tower. So Toronto's got a big problem, and Bruce acknowledging here. Testing the allotment plan assumptions. To Mark's question, in Canada, by the way, if anyone doesn't know what the allotment plan is, Industry Canada has awarded every existing broadcaster a new frequency. So, you know, if Global went to the Industry Canada and said, okay, what's my channel in Toronto, they can give you a number. If you want your DTV channel now, you can get it. Now, those frequencies and that distribution is based on an assumption of how powerful, how sensitive your receiver is, what your height of your receive antenna is, and in Canada, they assumed that there would be a line amplifier on that antenna. They figured, and they assumed the height of that receive antenna to be 9 meters. They figured if anyone was going to put up an antenna, they're going to put up an antenna. And if they're going to put up an antenna, they're going to put a line amp on it. So all of this affects your coverage area. Your coverage area affects how many channels you can fit in and whether you got interference or you don't have interference. These are big assumptions. So in the U.S., they didn't factor in this line amp. Another thing they didn't do is they didn't factor in indoor reception. If you have a second set, you just want to put up a set of rabbit ears, does it work or doesn't it work? So these assumptions we want to test in Canada. And Wayne Stacy has been a big flag bearer of the need to do this. And I know there's been, and I asked the question too, why do we need to retest? The fact is the U.S. used different assumptions, and Industry Canada used their own, and we're faced with having to prove these. And the test transmitter in Ottawa and the test in Montreal are to help substantiate that. Interoperability, I alluded to this earlier. Terrestrial broadcasters, signal is in VSB, cable is in QAM, and satellites in QPSK. How do you get this all to happen? And there are other parameters that have to interoperate, and you'll see more when we hit the displays. Okay, receiver and display issues, the last block in my system map. How are they going to be packaged? And I have a little drawing to make my point. Functionality, what's in the receiver? Does it have internet? Does it have over-the-air cable and satellite receive capability? So that has slowed down a lot of the receiver development, as well as standard setting, conditional access and encryption, program service, information protocol. This is how the system knows, how your receiver knows what channel you are, especially if you're transmitting 4 streams. It needs to be able to decipher what it is you're sending. It's also important for the broadcaster if they want to do directed transmissions. There's been some talk of sending the west side of the city, the Ford commercial, and the east side of the city, the GM commercial. I don't know why you'd want to do this, but that kind of thing, directed advertising. And you need to have these program service information protocol right and everyone understanding it. Now, cable needs to do the same sort of thing. So the two have to agree with each other, or the sets aren't going to be able to decipher things. The SAE is software application environments. The ATSC signal has tons of bandwidth, and you can download Microsoft Office in no time flat. So there's work going on in what are the protocols used to send these software applications to the boxes, to the receiver boxes. Copy protection. Believe it or not, there's a fight over, I don't want to use fight, there's a debate over the standard of how do you copy protect this, the digital content, as Steve alluded to earlier. Page down. Okay, enhanced features, I touched on that briefly. The capability of the display, like just how many lines are you able to get out of it? How big is the display? And cost. You've seen some of the numbers. Okay, here's the slide I've been holding off on. This is a simplified layering of the receiver, and I'm assuming the receiver, or set-top box, or it's been called a number of things, is separate from the television. And I think that's a way it's going to go. Although I've heard of some packaging the receiver box as part of the display. Now, you've got to deal with the front end. You know, what kind of demodulator, over-the-air cable or satellite. Not a big deal. I mean, the costs of the demod chips are not that expensive. I missed a slice in here, which I apologize for, and that's the slice that is decided. It is MPEG-2 and AC3 decoder. So all the boxes have to have the same decoder. We got something that everyone agrees to. But here are the 4 layers that are still in debate. Conditional access, program service, information, the supply, software application, and the copy protection. There has been agreement that the link between the box to this display would be the 1394 link. This is a 200, help me here, 200 meg, 400 meg bandwidth that can take the HD stream to the display. Now, it's here that the movie industry is quite nervous about, because you take that into some other record device and you got a pristine signal. So they want copy protection on that pipe. And there aren't going to be any boxes released with this interface until there's copy protection. So that's what we're facing in getting receivers on the market. Now, one other point I want to make about conditional access. Looking at this, I want you to think about today's model, a cable-ready set. Okay, you take your TV home, you plug it into cable, assuming you're paying for your subscription, and you got pictures. Now, there's some notion that, and I know Roger's going to talk about this and do a better job than I am, but conditional access. I mean, cable wants, is going to have to control these digital signals. What packages do you want? Now, broadcasters are talking about doing the same thing, especially if they're going to offer multiple services. So there is an issue about the format of conditional access and encryption and what is a cable-ready set. And I'm going to stop there because I know Roger will do a better job on this than I will. But there is right now a sort of a battle in the works, and I don't want to use battle, about who controls the gateway to the display. And I see David getting up. I have 2 more slides. Just some musings, just to close things off, that we have to do as an industry, and as Carol said, I mean, we don't want to create technical exercises for no reason. We want to work with the other working groups and with industry at an appropriate time frame. But let's divide the issues into small tasks. Let's not try to bite everything off at once. Identify clearly what the issues are. Let's not argue about this versus that until we're clear on what it is the issue is. Identify test trials with clear objectives. And a couple of ways I thought we can get the industry going is is build a shared over-the-air service. You know, the transmitter site in Ottawa may be a beginning. The U.S. has enormous resources, as we've heard, and we have manufacturers building training mobiles. Harris has done one. There are test facilities, a test station in Charlotte. You know, who has the pockets, other than maybe these guys, to do that sort of thing? But we might want to think more about sharing resources. And another one is operating a shared cable channel. This is for the specialties and for the over-air as well, and or satellite channel, where everyone can program certain hours of the day from a shared master control to get some experience. These are the sorts of things that we're going to have to try in Canada. We need Canadian developers, product developers, to assist with standard-setting process. These are the Leach, Miranda, Ross, Genham. Many of the standard-setting committees in the U.S. have participation from the guys in the labs who are developing this hardware, and I'd like to encourage the same from Canadian. We need your help. This is a personal thing here. Growth of DTV will require a low-cost home player. I've heard, I think Pat mentioned that there could be a under $1,000 high def. I don't know, was it VHS or DVD?
Digital VHS, it's $1,000 US.
Okay, that baby is going to start things happening. I bought a DVD last year. I went out and bought a home theater. Why? Because I can go out and buy the movies. You know, people aren't going to buy these sets just so they can watch an hour or two of high definition. Let's keep things simple. Let's work together, and let's be practical. And do I have time for an anecdote? Okay. The let's be practical part. There's 3 chaps out golfing, a priest, a surgeon, and an engineer. And they've been golfing all day, following this foursome, and just time's dragging. And these guys are shooting balls all over the place. And finally, they flag down the marshal, and they say, what's going on here? These guys have just been tying up the course. And he goes, oh, you got to forgive those guys. They're 4 firemen who were blinded trying to save our clubhouse. So we let them golf here whenever they like. So the priest said, oh, my goodness, I feel so sorry for those guys. I think I'm going to say a prayer for them. The surgeon said, tomorrow I'm calling my ophthalmologist buddy, and I'm going to have them examine and see what we can do for them. The engineer said, why don't they play at night?
Thank you. Thank you, Lou. Do you have any questions for Lou before he gets away? We're going to have another opportunity to give him some later. Anything? Okay. Then what we're going to do now is kind of cut to the chase and come to the end of the delivery system in Canada, the cable system. So our next presenter is Roger Key. He represents a key player, and I do not intend any pun by that, in the Canadian DTV scenario. Roger is Vice President, Technology and Strategic Planning of Rogers Communications, Inc. After graduating from the University of Waterloo in 1973, he entered the cable industry, working primarily in the community television field. He joined Canadian Cable Systems, now Rogers Cable Systems, in 1980, and worked on the acquisition of cable television franchises in the United States and on interactive cable applications. In 1983, he moved into the emerging cellular telephone industry to develop elements of the Cantel license application. He became their Director of Engineering Planning and was later promoted to Vice President of Engineering. In 1991, he transferred to the parent corporation, RCI, to assume his current position, and in the fall of 1988, he added leadership for the digital television project at Rogers Cable Systems to his responsibilities. Roger Key.
Thank you, David. Just to get started, what's the difference between HDTV and a UFO? People have seen UFOs. More people have seen UFOs. I find myself in that interesting position of being the 4th speaker after just about everybody else has exhaustively explored the topic. So I'm not going to use my PowerPoint. Instead, I'm going to try and crunch it down and just do it by talking to you. So we'll see how that works out. My presentation is called HDTV, the Standards Challenge. And the reason I said HDTV rather than just DTV is because it's arguably true that we have a digital television system in Canada today. And if you go and you look at a Star Choice or an ExpressView dish or Look TV or Shaw's digital cable, you'll find a digital set-top there, and it literally inches from the TV, the signal is still in digital form. And if you look at the other end of the pipe, you'll find that there's people with serial digital studios, and they're going to the uplink sites by serial digital facilities, and the whole thing right to the television is some form of digital transmission today. And it's only that last piece, the analog connection that's there, that is analog. And the only reason it's analog is because that's what TV sets have on them today. So I would argue that at least as far as standard definition is concerned, we have a digital television system right now. So some of the issues that come up for cable arise only when you get into high definition, because that's where the whole thing starts to break down and you end up with needing some new interfaces. Now the HDTV standards that are being created were really developed by the US FCC, and they were aimed and focused at over-the-air broadcasting. And as such, they tended to be somewhat incomplete as far as broadcast distribution undertakings are concerned. That is, cable companies, satellite guys, and microwave people. So something's got to be done. First of all, you've got to remember that cable and the other BDUs live by selling television services, and so we have to have a mechanism for, to control access to services. Secondly, cable has to optimize its use of bandwidth. They can't just afford to throw a bunch of things on. Its bandwidth is not free and it's not limitless. So we have to be very careful about how we use our bandwidth. And we still have demands to place additional analog services on. That era isn't over yet. Finally, and it's been touched on by some of the other speakers, there's a very important requirement now to provide a secure connection all the way through the chain for the copyright holders. They do not want to allow content in high definition form out into an environment where it can be readily recorded by customers. So there's three issues that we really have to cope with. Now, as far as the copyright issues, just so you understand what it really is, that the people who own the copyrights are not satisfied with an inch of wire with an unprotected digital signal on it. And just to give you an idea that part of it, and I'll talk a bit more about this later, is that there's a thing that's being developed called a pod. It's a plug-in device, and they want the interface on that plug-in device protected. It has to be encrypted, and I'll tell you a bit more about that later. But it has to be a complete system. They've been burned with CDs. They know people can go out for $360. You buy a CDR, you stick it in your computer. It comes with the software, and you copy CDs. They don't want that to happen anymore. And in fact, they really want to eliminate the analog interfaces because those aren't considered to be very secure. They're quite easy to defeat the copy protection systems that are out there. Cable, of course, has a history. Its analog history is that it has used filters, just straight RF filters to control access to service. That's a clumsy technology. It's hard to operate. It isn't consistent with going into a modern digital age and certainly into HDTV. We have to be able to use the kinds of technologies that have been developed for digital cable systems. Sitting underneath them are things like desencryption to encrypt the bits, and very sophisticated, although currently proprietary, conditional access systems that pass the keys to decode those signals over the network. Those exist today, and all through digital cable, through satellite, and through MMDS systems. Now, going to transmission, digital transmission systems we have, 8VSB that's proposed over the air is fine. You need a rugged signal over there, but it's not efficient when you try and take it into a cable environment. It's at 19.4 megabits per second. Typical cable today at 64 QAM is 27.3 megabits, or if you go to 256 QAM, it's 38.8. That's twice what an HDTV signal requires over the air. So we can't sit still with it. We can do much, much better, and we just can't use 8VSB. And the reason, of course, is that cable is actually a very low noise environment for a digital signal. In fact, we don't even have to run them at full signal level. We can drop them down below the level we use for transmitting analog signal. And the 256 QAM and the 64 QAM are well proven. There's over 1 million digital set-top boxes in operation today in the United States on TCI systems alone. So this is not something flaky or different. This is well-established technology. And I can tell you from our own experience that 256 QAM works very well. It's very rugged. We've thrown it into some difficult systems. We have it actually up on our plant here in Toronto today, and it's working very nicely. So we really need to keep that efficiency, and we just can't use 8VSB. As far as the cable technology itself is concerned, the digital cable technology, what is in place today is largely capable of handling the HDTV signals. We have to have HDTV input, and we have to have a device on the end. But the pieces in the middle really don't care that it's HDTV at all. What we sometimes term it is a fat PID from the MPEG terminology of program ID. It's just one with more data in than the rest. So the systems can do it, and the encryption systems can handle these as well. So we're not looking for pieces there. It's not even the front end with the compressors. You can buy compressors. You can get the system. It's only what happens on the end of it when you get to the set-top. The pieces we are missing are, as I mentioned, the set-top and some BSB to QAM conversion to put in our head ends, and even that is under development right now, and some of it was displayed at the Western Cable Show in December this year. There are some HDTV set-tops being built in very limited quantities with analog outputs, because that's what's available on HDTV sets today, but they cost about $2,000 US, and not exactly something we're going to deploy on a widespread basis. But they're out there and they're available in those cases where they need to be used. And of course, the reason they're expensive is because they have to include a full HD decoder. So if you've got someone who's got an HDTV set, you're idling the HDTV coder inside the set in order to put a set-top on top to do the same job. And the only reason you're doing that is to maintain control over program content and to be able to avoid the problem of having an unencrypted digital stream available in the home. So what's happening, as I mentioned earlier, is that the FireWire, or IEEE 1394 interface, has been adopted as the interface standard between television sets and a whole variety of digital devices. VCRs, DVD players, computers will all talk to each other over the 1394 standard. It's well established already, and it comes in different flavors of, I think, 100 megabits, 200 megabits, 400 megabits, and it has the capability to do the job that's required. Sitting on top of that is an encryption standard. So we've got three now. We've got encryption over the satellite, we've got encryption over the cable system, and now we've got encryption between the set-top box and the television. There's been a lot of debate around that, but it seems to have settled on a proposal called the 5C proposal, and it comes from the companies that proposed it: Intel, Toshiba, Hitachi, MEI, and Sony. There's still a little bit of dissent from Thomson and Phillips because they weren't in the standard, but I think that's going to go away over time and we'll be settled down on this 5C encryption. So that solves one of the big problems. Now we can say to the content owners, we've got a way to secure your signal from the input of the system right through inside the display device so that you aren't at risk. We can control how that signal is used and how it's recorded. Now on the issue of timing, when is this stuff going to be available? As best as I've been able to determine from talking from people who are close to this issue, that it's probably early 2000 when we will have both digital set-top boxes and digital HDTV sets with a 1394 interface on it and the necessary electronics to work with the C5 encryption. And perhaps Pat Whittingham could also comment if he wanted to later on how things are going from his perspective, but the read I have on it is that it's something that's going to happen probably in the first or maybe second quarter of the year 2000. And if you put that in the context of where Canadian HDTV is, it doesn't look like it's going to present any kind of impediment. You take the 18 to 24 month time frame, that says May 2000 is about as early as it's likely to start, and I think we're pretty much in the right window. And in fact, if you take a look at the reality of television, they like to do things for the fall season, and that would mean that probably HD would be likely the fall of 2000, if anybody really wants to do it by that time. So I don't think that there's going to be an issue as far as cable being able to distribute an HD signal, have it go through a set-top, and actually pass out into a consumer receiver while meeting the requirements of the copyright holders that they be completely protected from end to end. Just looking a little bit further, but not too much, cable industry, through Cable Labs, it's sort of R&D organization for the industry, has been developing something called Open Cable. And the purpose of Open Cable is to take the set-top out of the cable proprietary environment and put it into consumer electronics. And by doing that, people will be able to go to the store and buy a digital set-top or buy a TV set that includes the functionality. So one piece is missing in that, though. We still need the ability to control who can see which programs. And that is being accomplished through a thing called a point of deployment module, or a pod. And the pod basically looks like a PC card form factor. It'll plug into the decoder or plug into a television set and enable the conditional access. And that is where I told you that fourth piece of encryption. There's something being put in between the card and the internal workings of the set-top or the TV, so that even over that interface, it doesn't become open. Nobody can stick this on an extender card and read the signals because it's encrypted again at that point. So now if you count them up, there's one over the satellite, one over the cable system, one on the card, and one out through the 1394 connector. So it's been through at least 4 encryptions by the time it arrives at digital television. And we're really fortunate it's digital because you sure couldn't do this in analog. Anyway, the pod devices are mandated by the US FCC to be available by July the 1st, 2000. So in almost the same time, there's going to be 2 ways in which a digital signal can arrive inside of a digital television set and get around some of the issues that we think might be an impediment to an HDTV deployment. So I guess in summary, I don't think that while there is some cleanup work to do, I think the problem of HDTV on cable is substantially resolved. And I think that there's no reason that we should think that anything to do with cable's ability to deliver the signal and have the technology in place should be an impediment to any kind of a digital deployment, HDTV or otherwise. Thank you very much.
A very positive note, Roger. Any questions for Roger before we have a break? If
You look hungry.
We'll have an opportunity to do it after. We're going to now have a 10-minute break, after which we come back. And after the break, we have a panel discussion with some DTH and off-air broadcasters and talk about their plans for implementing HDTV. Thank you. See you in 10 minutes. Thank you, Roger.
Of the presentation, and perhaps a piece of interest to everyone, is that we're always going to put out a multi-channel MPEG-2 service, and that'll have a range of qualities on it, ranging from the current quality we have right now with NTSC standard definition, SD NTSC, which is the 544 style of resolution. It'll start to include super definitions this summer, and high definition signals will probably, there'll be a couple maybe by the back end of next year, but we won't really be rolling too many out until the year 2000, early 2000, but we will be having some true high definition signals on the service by the end of next year. The super definition signals will work with our current standard definition set-top and will be available to all our subscribers, all our existing subscribers, as well as the new subscribers that might choose to buy the premium high definition set-top. The high definition signals will only be viewable on the premium set-tops, which will go on to market late in 1999, probably just about ready for the Christmas sale season. And we'll determine when we phase out the non-high definition sales. The last bullet point on that slide, and what I think is very, very important, everyone should understand, is that all the program signals on our service will be encoded, multiplexed, and configured by ExpressView. That's very important. We've been very open about that and how we plan to do that. Finally, a couple of important points to remember. Maybe not totally well known, but just how successful the Canadian DTH launch has been. Both ourselves and our competitor, Star Choice, have launched much faster in Canada and have penetrated much faster in Canada than we expected. It's just been a wonderful 18 months for us, and also for Star Choice. It's been actually per capita much faster than the United States. Our penetration has just been very, very fast, and there's lots of good reasons for why that is. An interesting point is that to some of the premium channels that exist now, particularly the movies and the pay-per-view channels, based on the subs that we have and the subs that we think that Star Choice has, and making the assumption they have roughly the same number of subscribers as we have, Canadian satellite DTH looks like approximately a 2 million subscriber cable system. So we're, to the movie networks of this world, we look like 2 million subscriber cable system, and that's a very important statistics. It shows just how significant we are in terms of how many homes we actually meet for many of our specialty networks. And this is just growing, and it's growing very, very quickly. The other topic that's relative to that is that many of the local stations that we carry and that are carried by Star Choice, they now reach more TV homes via satellite than they do from their transmitters and their cable systems. From some of the smaller cities in Canada, their local news and their local commercials and advertising now reaches more people via us than it does via their transmitters and cable. And we think that that Canadian satellite DTH is perhaps the most cost-effective way to deliver high-definition signals across Canada, economically, sensibly, and to the point where people can get a full range of channels and services that make sense to them when they turn on their TV. That's Bell Express View.
Thank you, Terry. I think we'll be coming back to some of those issues in a little while.
Absolutely.
Next, we're going to hear from Bruce Cowan. Bruce represents over-the-air broadcaster. I was almost to say a traditional broadcaster, but it's City TV, maybe anything but traditional. Bruce, well, what's happening in your part of the world?
Well, I am going to try to remain focused on over-the-air transmission tonight. We, of course, do operate other services, but I've been asked to speak to the over-the-air issue. What are we looking at for over-the-air? I feel that it's like we're at a party and we see a beautiful girl in the room and you like her and you want to talk to her and you want to get to know her, but you keep circling her and you're not sure whether or not you should ask her for a date or for a dance because you're not sure how it's going to work out. And I think that's kind of where we are with digital television. We like it, we think we see what's out there, but you're circling, trying to see where this may go. I also think it's appropriate that we're on the Grumps set. That seems quite good.
You're certainly not concerned as you won't still love her in the morning, are you?
I hope so. Certainly for over-the-air, traditional over-the-air broadcasters, I think we're at a very important time, obviously. I think certainly the game has changed and the game is continuing to change. For City TV is a UHF over-the-air broadcaster, as everyone knows. And I think we've learned with UHF, we get a lot of calls, people saying, I can see the CN tower where the transmitter is, but I have difficulty receiving your signal. And often we find that that's because City TV in Toronto is operating on channel 57, a fairly high channel. And often it's because people that do have outside antennas have connected that antenna with a coaxial cable, which is extremely lossy at UHF. And when we talk about preamps and antennas and things, I agree. I think that UHF, we have to be cautious there. That can be problematic because it's that last 100 feet that can be a killer at UHF. At last year's CES show, I heard some American broadcasters, over-the-air broadcasters, talk about the fact that once we're digital, the viewers will come back. They'll then watch our programs. I thought then that they didn't understand that everybody else will be digital too. I also hear people talking about in the new world, to get over-the-air television, people will go out and buy a TV. They'll buy this big antenna and a preamp, as I think Lou mentioned. And they'll go up on the roof and put up a tower or something and put up this antenna. Well, how many people are really going to go out and put up an outside antenna to receive 3 channels? I wonder where that's going. I think they may put up some other type of antenna.
I like that. Small 18-inch dish, that'd be good. Awful lot of channels on that little dish.
And I think if a broadcaster, if an over-the-air broadcaster wants to look at this seriously, they have to consider what the marketplace is doing out there in terms of reception. I think to go back to that old model of all of us having antennas up on our roofs and 300-ohm twin lead running down into our TV so we can get UHF, that's gone. There was questions earlier about, does Canada need to do our own tests? That was a question we raised internally. Do we need to participate in this over-the-air test? And because we thought, well, maybe we could just do what the Americans are doing and follow on through. But certainly Canada is a different marketplace. We need more information on signal penetration into the home or into the apartment without a large outside antenna. We need to know more about that. In Canada, our low-power television transmitters are a different situation. They tend to be associated with larger broadcasters, and these are like small transmitters that may fill in certain marketplaces versus in the U.S. where it seems like almost anybody can get a license to put up their little low-power TV transmitter in town. So things are different in Canada, and yes, we do need to study that and see where it's going. I think it would be a mistake just to simply follow on through with what the Americans have done. Personally, I have trouble with the American model that sits out there with everybody's putting up 2,000-foot towers and running 5 megawatts of power to feed those homes out there with these antennas. It's a new world. I had hoped that with digital television, especially with over-the-air, since we are, let's say, consuming a public commodity, and that is RF spectrum, that digital television would allow us to fix some of the problems with NTSC analog. Specifically, the problem of, at the moment, we really cannot transmit our pictures to moving targets. For example, taxi cabs, limousines, buses. Wouldn't it be great as an over-the-air broadcaster if you could transmit your images to moving targets? Wouldn't it be great to sit in Skydome with a digital handheld receiver and watch the Jays in perfect quality on that TV? But there's a number of problems with that. One is the...
One is a condition of the Jays, I suggest.
Let's not go there. I'm waiting for your joke. I haven't heard your joke yet. There's a couple of problems with that. One is the 8 VSB signal truly robust enough for multipath and moving receivers? And how do you get all that silicon shrunk down to go into a little handheld TV that we have now today in analog format? It's disappointing that maybe that part of it hasn't evolved and may not evolve. The issue of program guides, that at the moment a station like City TV will basically hand over our schedule to ExpressView or Star Choice or somebody. They will build the program guide, and we rely on them to deliver that to the consumer. Will the over-the-air broadcaster now have to take that program guide upon himself and put that in the data stream for the person at home who receives the over-the-air signal? Will we now have to produce that content and put that into the data stream? At the moment, we essentially hand it over. Just the sheer issue of transmitters. I was somewhat surprised when the task force report to the minister came out, a year and a half ago now, and I was somewhat shocked to read that it recommended that we implement over-the-air transmitters in Vancouver, Toronto, and Montreal. And I thought, that's interesting, because I don't recall anybody asking us who have to put the transmitters in if we can do that. Because at the CN Tower, specifically in Toronto, there's floor space issues to physically put the transmitters. There's antenna issues. There's really no space for any additional antennas. There's feed line, transmission line problems, capacity. In terms of floor space, if you're going to put in a digital transmitter, in our case for City TV, we would have to remove our standby analog transmitter to make room for the digital transmitter. Well, now you no longer have a standby transmitter for your main analog service. So does that mean you also have to purchase a low-power, small transmitter and somehow shoehorn that into the room to be able to maintain your analog service, which for the beginning will continue to be your bread and butter? Does your transmission line on your tower, is it capable of handling the additional power of that digital signal? Do you have to put up a new transmission line? If you have a tower like Chum has in Barrie or Woodstock or London or Ottawa, Pembroke, or out in Alberta, traditional towers, it's the loading of the transmission line and the antennas to go on these towers. The tower that we have in Barrie is heavily loaded. Everybody that wants to radiate RF is on that tower. And now that that tower, a lot of that space has been leased out to others, we now have a problem of where do we put a digital TV antenna on that tower. There's the cost of transmitters. A couple of $1 million per transmitter site. For Chum, this can translate into $20 to $30 million just to implement digital television. And this doesn't even address the studio side of things. This just gets an RF signal out there. And the over-the-air transmission, really, when you think about it, over-the-air transmission is really the free service. It's the thing that we can all go out today and buy a TV at Canadian Tire or other stores for $59. $59. Black and white maybe. But you can take that home and set it down and you can watch television for free. And that gets to you through over-the-air transmission. And digital over-the-air will still be free. And the difficulty is the over-the-air broadcaster is essentially being asked to install an infrastructure like transmitters and antennas, et cetera, to provide a free service that people don't have to pay for. Now we are using RF spectrum, of course, public property, but it is a free service to get the same viewers, of course, that are watching us today. So the thing about over-the-air is it remains the free service. It's not something you have to subscribe to and pay a fee for. And of course, the receivers for that will allow it to be viewed without any kind of encryption. Over-the-air broadcasters are going to be into a new world. And I think for us, we tend to sit here in Toronto when we view things with a perspective of cable, satellite, and other services, and we have almost blinders on. If you get out into the other regions of the country and this province, things are different. How does a station like CHRO in Pembroke, how do they survive? How does a station in Barrie survive in the new digital world? Things are difficult enough today as it is. So for over-the-air broadcasters, it will be an entirely new world. And I think they have to have a practical approach to it. Otherwise, that new world is going to be extremely difficult for them to play in.
So I guess we're hearing rather clearly, Bruce, that over-the-air broadcasters are facing several challenges in doing this. But there's another point you made that I found rather intriguing, and that was the notion that also we'll be looking at maybe a more level playing field. If everybody is digital, there's less to differentiate the various players. And I wonder if Harvey has that same kind of notion coming from the specialty point of view.
Well, I would like to, first of all, describe what a specialty channel is, given the fact that that's a word that could be misunderstood in the United States and around Canada. A specialty channel is basically a theme channel, and that already restricts the audience. You're going to tune to a sports channel or a history channel or a gardening channel to get information regarding those themes for that particular time, whether it's an hour or a half an hour or a movie or whatever, with some particular theme behind it. So that then restricts the number of viewers we have. So we start getting into this dilemma. How many viewers are going to be watching us for the half hour? How much ads can we sell? Where are we getting our revenues from, et cetera, to be able to generate the capital investment in order to go forward with this kind of new television. The specialty channels in Canada have ads as a revenue source and subscription. So how many subscribers are being sold on a tier in order to see the programming? That becomes an issue as I go further on in my little dissertation here. And today's specialty channels have a greater viewing capability. Some of them are up to 8 million, some are down to 2 million, some are at 3, 5, depending on how old that specialty channel is and what is the penetration in the cable systems. The new licenses that we're looking at, and there were 71 that were filed with the CRTC just over a year ago, and they're going to come up for a hearing shortly, are all based on a digital model, meaning that the set-top box is going to be the environment. And how many set-top boxes are there going to be out there? There's not going to be 5 million. There's not going to be 8 million. We heard from Roger that the penetration is going to be small. Right now, there's probably 50,000 with Shaw, and Rogers really hasn't started to roll out, and Cogeco and Videotron. So when you put them all together, there may be a grand total of a million, compared to the 5 million that you have as subscriber and ad revenue from an older station. So what you're seeing is that the economics for us to start to get into this sophisticated high definition side is becoming less and less attractive to us for a very small viewership. The other thing I wanted to mention too is that the specialty channels are now having two types of support. Either you are the independent single specialty that has to stand on its own without any support from a broadcaster, or you get a broadcaster who has 5 or 6 channels or 2 channels, and therefore there can be some cross-subsidization between the power bases of economics. And the last thing on just the start here is that it's a quirk that the specialty channels do not need a digital license. we can do it tomorrow, where the terrestrial broadcasters have to have a digital license, an allocation of spectrum, et cetera, in order to get started. So the people that are less able to do it have no problems getting forward through the regulatory process, and the ones that are willing to do it, which is the terrestrials first, are having to go through all this rigmarole with the regulatory. Anyway, what are the problems that are facing us? Most of the specialty channels have analog plans. So we have to then do a conversion. And let's remember, when we're talking about this new type of television, we're talking about a digital signal. We're not necessarily talking about a high definition. So you have two modes of jump. One is to get to the digital platform, the next is to get to the high definition. And the Canadian Task Force said that that digital should be widescreen. So that's the only little quirk between the 4x3 and the widescreen that is the first rung that one has to get to. Second, we're all distributed, as you heard, by satellite or other distribution systems. It's a bandwidth issue. How many megabits can we put on the satellite to be able to live successfully? And as you go into a higher bandwidth scenario with high definition, it's going to be an issue for the distributor of how many high definition channels that we're going to put out there. There's about 34 different specialties. Does it mean we're all going to jump into high definition? No. What is the real prime product for high definition? Everybody should be digital. That's the same bandwidth. That's not an issue there. It's really the high definition side. So you would say the movies would go there, the sports product, but you have a high definition cooking show, you have a high definition histories, you know what's going to drive us to go that extra step as a specialty? Compression, I mentioned, we're trying to save on the distribution costs, so we're making sure that our product looks good, but trying to make it in the smallest bandwidth. So to jump to the next one, again, it becomes an economic justification. And then what kind of programming are we going to buy as a replay scenario when you would get a showcase or a women's television or any of these others that are depending upon distributors to give us product? There isn't that product out there. It's first the movies, and it's the first run movies. So that's the premium services that are going to have the opportunity to do the widescreen and the high definition. If you're looking at in a showcase where we're playing Forever Night as a Canadian product, that's already shot. We have an option. We could take an encoder and we could stretch it and we can up the resolution and put it out there. That's one way of doing it, but that's not giving us the true definition that we would want to have with a digital system. So that becomes an issue. So the second thing that we have to do is upgrade ourselves from the analog to the digital and get into a widescreen format. The next thing is to say, how are we going to justify the high definition? Are we going to take the easy loop and go through the upgrader, translator? Are we going to actually have to put in digital cameras, high definition cameras, high definition playback VTRs at millions and millions of dollars of cost? So that becomes another issue. And lastly, I would just like to say that probably the most sensible thing that was said here tonight is that the Canadian broadcasting industry get together, get a transponder on a satellite so everybody can see it, and we do a common channel. Those that have the capabilities and those that have the desire to jump forward would contribute programming at the start while the sets are rolling out. And once we could maintain an 8 or 10 or 12 hour distribution every day. Remember, it's a simultaneous broadcast. We would still broadcast in the analog that same program that we would flip into high definition for those that would have the receiving capabilities. And then once the service is flush with programming, then you drop that common channel and you go back to your original. You're not going to lose anything, but at least you have a combined output so that the people who are investing in this new technology are not going to do it for an hour here and an hour there and then have to know exactly where it's going. It's so easy to say, watch it on channel 42 on your high definition, and here's the program schedule, a little bit of everything. It's a sampler channel, and what a wonderful way to start. Anyway, I don't want to take up any more time, but in the discussion I'll bring up my other ideas.
We're going to come back to the idea, I think, of having a common channel and maybe explore that a little more. But you also mentioned that you thought maybe some of the better heeled private broadcasters, off-the-air broadcasters, may be sort of jumping at the bit to get into the DTV world. I hadn't heard that. That was something that I hadn't heard earlier. Maybe Rudy, as a representative of the People's Broadcaster here, could comment on that. Rudy?
You don't have any more money either. First of all, I'd like to start by saying that I just found out a few minutes ago that I had to sit in the hot seat here, so my comments will be very, very brief. First of all, we certainly are interested and would like to start to bring a digital quality signal to the homes. I think it would be very good for people in the homes to actually see the kind of signal quality which we have gotten used to in the production facility. And I think just doing that in a normal digital format, never mind. Just to give you some idea, however, of the scope of the project for the CBC, we have some 24 production facilities for English and French television across the country. We have some 600 television transmitters across the country. So even if we were to consider to just convert a small portion of these transmitters, or only the few key production centers, the costs involved are humongous.
Have I got a deal for you?
No comment at this time. We are in a bit of a more fortunate situation in Toronto, however. Here we are already operating in the serial digital domain 601, so it would actually be fairly easy for us to actually take that signal, put it into an MPEG domain at the output, and send it to our transmitters, certainly in Toronto, and some of the key transmitters in other areas. That would not help any regional insertions, etc. But at least we could do something inexpensively as a start. In conclusion, pardon me?
Inexpensively?
For Toronto, for Toronto, because we already have the digital distribution facilities. We have camera facilities which are 16 by 9 switchable. So we actually have that. We are in the process of replacing in the near future most of our news gathering inventory, which will then be 16 by 9 compatible. So that is already in the making. So we have a little bit of advantage here. So
Is there some possibility in this from a Canadian scenario, as well as having a single channel to be shared, to be kind of half pregnant, like not be all the way into HDTV? You mentioned earlier, Terry, that there was some experimentation going on with an enhanced version of NTSC done in a component digital world. Yeah. You have a component digital signal to begin with. We have heard earlier this evening that the sets, currently the technology limits it to the Shadow Master certain resolution in any event. Is there any kind of halfway that makes any kind of sense?
Maybe. What we found, David, was that there is an interesting step before you get to the full-blown high definition that does make an awful lot of sense. The key criteria is that it should never have been NTSC. It's something that has never been encoded into an NTSC signal that exists and that always existed as a component signal, properly encoded within the standard definition flexibility of MPEG with full 704 horizontal resolution and the right number of bits associated with it. Makes very, very nice television to the home, coming out of an S-video connector on the back of a set-top, because you end up with with a component signal end to end that the signals that you're looking at in your plant are actually coming out of the television in the home, and that's what we experimented with over the summer. We had our source, by the way, was high definition playback machines, and our original experiments would look at high definition capability, but we ended up realizing just how nice it looked when we had a very high quality source going into our SDTV encoders. I'd almost characterize it as DVD quality. That's our objective this year for certain channels and certain program origination, is that we hit the same quality as a digital video disc over our service. And I think that's quite achievable. I mean, that's what we're looking for.
Within the CBC plan, are you originating as component, delivering as component, and not going to NTSC till the end? Is that generally the quality of signal origination that's maintained throughout the plant?
Well, certainly throughout the plant, it's all digital. All signals coming into the plant are being converted into 601. Everything in the plant is done.
But it may come in NTSC already with the artifacts of NTSC embedded and then get converted.
At the moment,
correct.
The moment,
Okay.
Yes.
But the stuff you originate yourself is component all the way through?
Correct.
From
Yes.
the lens
Yes,
through the... Okay. Harvey, I'm sorry.
I was going to say that one of the things, and Lou certainly brought this up, is the AC3 audio issue. I mean, right now we're just standard stereo, And let's be clear about the cable. Not everybody is stereo. I mean, they're taking our stereo signal and producing a mono output. There's a whole retrofit that was going here. We've heard the two cable companies, and we were talking about Shaw and Rogers, who are putting the effort into it. And granted, they have the majority of the subscribers, but there's thousands of little guys out there that are not going to put their effort into the technology. So are we really beaming it across Canada? What are you going to do with a guy in the small town in British Columbia that's on a small cable system? What's going to happen there?
Harvey, as you know, when we, all of us moved to DVC on satellite, certainly in our Much Music service, we lost, there was about 500 small cable head ends that literally dropped the service because they simply could not afford to buy the receiver.
That's right.
And we didn't want to.
So this is a rich man's game from the cable side. It has to be a major center that will give you the full bandwidth, that will give you the full stereo capability today, and then we're asking about changing all of that internally in our plants, and then how do we manage this? And if we have studio production like City would have, it's a phenomenal effort. If it's just a playback system, it's a lot easier, but still, it's a whole retrofit. So where does that take place, and when does that take place in the whole scheme of things?
Okay, we have a question from the other studio. We have an overflow studio, and a not-so-little person is there to give us a question. Michael?
Yes, I have a question that was phoned in. It's from George calling from London, Ontario. The question is directed at Roger Kay, but it's relevant to what Harvey Rogers was just commenting on. The question specifically is, what is the timeline for full deployment, and when will all markets of various sizes be equally served by digital cable? I suppose that they're thinking that Toronto might get served before a market like London or even a smaller market in rural Ontario. So that's a question from George in London calling in from the satellite feed.
Well, that's a big question, because I'm not just going to answer it in the context of Rogers Communications or Rogers Cable. You know, we're a big piece of the industry, but we're not all of it. So I can't answer it for all of the systems. Rogers is actually very highly clustered, and something like in excess of 97% of our customers are either connected to our Toronto or Vancouver head ends. So for us, doing a digital deployment is not inordinately difficult. We have SONET network with fiber facilities joining these systems, and once we have those feeds available out of our Toronto or Vancouver head ends, it's not very difficult for us to deliver it to most of our customers. Beyond that, of course, there's lots of people who depend on satellite feeds, and they will just pick their own time frame about when they actually take service. I'm really not too prepared to talk about what our timeline is, other than sort of generally second or third quarter this year. Ought to see us rolling out our digital service. That's it.
Okay, Roger, while we have you there, a question for Terry that you may wish to comment on as well. Terry has the capability, I think, within the DTH system to rather rapidly provide this enhanced signal to people's homes. If they have the ability to receive it and display it through an S-connector, he can provide a quasi-HDTV service now. I don't know whether you're intending to do it or not, but does that kind of thing influence the cable system's interest in accelerating the introduction of the digital service by cable, or you're just going ahead with the current schedule, there's just no way of accelerating it anyway?
Well, I guess I think both of us live within the same MPEG-2 standard, and the only way you're going to get maximum resolution of the system is setting up your encoder what's called full resolution. There's basically 3 settings you can put on an encoder. Full resolution, which essentially passes 601 bandwidth, and perhaps our friends from CBC don't know, but we have actually hooked up to their plant through 601 feeds and put it out on our system as full res 601, and it looks really nice. I compliment you on the quality of the origination. But there's other people out there, TSN, we've done it with TSN. Even our humble little shopping channel is actually a full serial digital implementation with 16:9 cameras in it, switching, monitors, the whole works. I asked the guys one day, how long would it take you to go 16:9? They said, give us an hour. So there's plants out there that actually are able to do this sort of thing today. Yes, it presses us in a sense of what Terry does, because we're in a competitive environment. We've got to watch him, he's going to watch us, we're both going to watch Look TV, and we're going to see what they're doing. And there's going to be a what does the market want here situation. Right now, most of the encoders that are set up at 3/4 resolution, which is better than you get off an NTSC transmitter. It's got more bandwidth, but it's not out to the 5.5 megs or so that it's capable through an MPEG system running 601 when it's properly set up. So yes, there's some pressure there. Running a widescreen through it is just a matter of sending an anamorphic 525 line signal into the thing. It'll go out that way, and when you plug it into a widescreen television set, you get widescreen out of the end of it. Some devices are capable of taking that widescreen and crushing it down into a letterbox format, which would allow the same widescreen signal to be seen on a 4:3 television set. And the other part of it is pan and scan capability, which is within the MPEG specification, but there's really some weak links there in the studio end of it of how to convey along the message about what part of the 16:9 you use to create a 4:3 panel. There's work being done on it, but it's not complete, and it's not something you find on a tape that tells you where to take the sample out of it. So there's things that can be done, and I think it's a case where the transmission systems are actually capable of doing more than we're actually making them do today. The same thing with, there was discussion about AC3. You can set up AC3 for full dynamic range. You can set these dynamic range parameters. You have to set your dialogue normal levels. There's all kinds of things that can be done there, which can, over time, allow customers to decide whether they want to have a full range presentation of their sound, or instead just have something compressed down because they're watching late at night and don't want to disturb other people in the family. Those are all things that can be done, and I think they will be implemented as successive generations of receivers, whether they're cable or ExpressView or MMDS, come along.
Roger, but I'd like to comment about, maybe the illusion that you're giving about what digital capabilities and quality that you're going to have on this box. You have a mix of the specialties who are using compression through the satellite at a very low megabit rate that are pixelating and not giving a totally sharp picture appearing on that satellite, on that digital box. You are mixing the standard broadcaster and the specialty, and there's a world of difference. So there has to be an upgrade to the specialty side. Not saying that we don't want to do this, but I'm just saying the impression you're getting is that if you roll this out tomorrow, you've got a tremendous amount of play and a lot of channels to be seen. You're talking about the over-air broadcaster, not the specialty. And I have to exempt the TSN probably, and certainly the movie network, which is a different flavor. I'm talking about the straight specialty channels. They're not going to be with you at the same level of quality that you would like to see.
Well, first of all, let me say I agree with you, and I agree with you not just in the context of digital. It's an issue even in today's analog, because the analog signals our customers are seeing on their plant today are coming over compressed digital satellite links, and they don't look good at our head end because they've been subject to overcompression because of the current satellite situation. I'm hoping that once we get satellite space back again, that people will open up, buy some more bandwidth and open up and improve their signals again.
Well, that's going to be the problem, because if we go to Terry, you're not going to open up the bandwidth and give us 6 megabits and say that's going to be a good picture for this.
What I'm saying is I am. What I'm saying is that right now Anarchy 2 is so bandwidth constrained that both ourselves, Star Choice, and every specialty network is fighting to put their signal up with as few megabits as possible. So for selected programming that comes to us in a form that's really high quality, we will definitely open up the pipe.
Well, you take ours as a baseband. We don't compress it. So you're saying that when you go to NIMIC, you would put us in a bigger bandwidth.
Yeah, absolutely. We'll assign to.
I'll hold you to that.
There you go. you give me some non-NTSC, some component signals, and it may be that you might want to be supplying me with a digital video disc. I don't know how we get the programming to us, but and it maybe you want to provide us with a master tape that's come out of the studio that's been, which a lot of the broadcasters will be giving us. That we have the opportunity of sticking it into our encoder
on a 24-hour service, giving you tapes. That makes sense.
I mean, a lot of the services can do that. I mean, movie networks, pay-per-view, all those services will be able to give us that kind of quality, and the CBC in a lot of cases can too. I think. I know they will.
A question for similar kind of question for the off-air broadcaster representatives that are here. If Buffalo, and I don't, forgive me Buffalo, but I don't know what market Buffalo was in. Whether
2002.
2002.
2002.
Okay. Let's say they jump the gun. That someone jumps the gun, and we suddenly find that there is DTV signals, off-air DTV signals in Toronto. experience has been, I think it was alluded to earlier, that they tend to travel at least as far, if not further. We have a report from one of our clients in Houston who says that he was at the fringe area watching a beautiful DTV signal from his transmitter and couldn't see any sign of his NTSC offering at the same location. So chances are they put a reasonable signal in Toronto. Well, that, if that kind of thing happens to come there, then people run around with Lou's 9-meter antenna and a preamp. Is that likely to make the local broadcasters suddenly want to do something more
It's
quickly?
happening now in Windsor, of course. Signals from Detroit are falling into that Canadian market. So that's real for that particular market now for anybody operating in Windsor. Certainly once, I think, signals start falling out of the sky in Toronto, that's going to get our attention quickly. It comes down to the consumer, and is the consumer going to start asking us questions, so when am I getting you in digital?
Maybe we should be asking, when are the television sets going to be available in Canada?
I'm just going to say, when he can go to, when the customer can go to Future Shop and buy that digital TV, and of course, Future Shop and other stores are going to want to sell it. And now the consumer is going to demand to get those signals. And just on the Future Shop issue, and Roger had mentioned the dial norm and other things, I just want to come back to the consumer and to the manufacturers. One thing that we did with City TV is we implemented the SAP audio channel a number of years ago. That taught us a lesson about the consumer.
It's an unfortunate name for a channel, but it's...
But that taught us a lesson about the consumer and about the complexities of the home TV set. We learned that people could not understand this thing called SAP. We all know what it is. Technically, we understand it. We can read the manuals. We understand it. But for the grannies at home, and for the TV remote control push button illiterate, they didn't understand this. And one of the concerns I have is we're going to make these digital TV receivers so complex by adding in dial norm things, and the consumer can do this and can do that, that I might come into the family viewing room and set a certain setting to watch my digital TV in widescreen with a certain setting for my audio. What happens whenever another member of the family comes in and sits down and they simply want to watch something else, or they start pushing buttons? We have to be very careful, and I think we should be working more closely with the manufacturers of the home receivers to make sure that we don't make this overly complex for the consumer.
We have some questions, some distant question. Mr. Martin again?
Yes, this question is for the panel in general. It's from Stephen calling in from Alberta. The question is there any Canadian market research to support the consumer demand for HDTV, or is this whole issue being driven by television manufacturers?
An Alberta question, yeah. Carol Darling would like to address that question. Carol?
Quick answer, in terms of recent research in Canada, I'd say no. But I do know in the States that the Consumer Electronics Manufacturing Association has actively done some of their own consumer research, telephone surveys, and they will tell us that everybody wants it. Some years back here in Canada, at our communications research facility, Advanced Television Test Lab, we actually did some very early market research with early HD, but I think it's a little bit outdated now, and I think we're all looking to see what happens in the United States.
Yeah, I can comment on that too, David. We not necessarily high definition, but higher quality signals. I was surprised, like the whole technical world, I think, is starting to understand that where we once compromised technical quality for the sake of content, people are now really starting to look for quality on their signals. The DVD disc is a big example of that, and our own market research says that people buy expressively.
You think we ever did that? Really?
I think we did. I can remember when I was many years ago being told, forget quality, let's just make sure we have the content there. And it's a refreshing
the audio
change.
world was so quick in jumping to the CD and
Absolutely.
digital radio, et cetera, et cetera. So everybody's got this digital world on their mind, and television is very slow to get there, but it's so expensive. But at the end of the day, the picture is fabulous, the resolution is there, the detail, the sound, and if you can afford to be in the game, you'll love it.
Yep.
We have another question from the floor. Mr. Montana?
Yeah, this is a question for Bruce, and maybe a bit of a statement. Bruce, did I detect that there's some hesitation in the logic behind building a transmitter and a tower and antenna and providing free digital television? Because if I did sense that, I've heard it from others.
You trying to put me on the spot, or?
No, well, I guess it's kind of a leading question, so maybe I won't force you to answer, but.
It's a good question, Lou. I think there must be some hesitation. People, we know that people don't receive television at home through over-the-air transmitters to a large degree.
Right.
Actually, just to get back to something, we know that we accept that 85% of Canadian homes receive their television via cable TV. But,
satellite.
I'm sure there's some satellite component in there as well.
But that was 2 years ago, right?
I'm sure the numbers probably have changed in the last hour or so. But
You bet they have.
but to be clear, there's many cable companies out there that still receive their signal from the over-the-air transmitters. So while it may be come into the home on coax, the signals getting into a lot of head ends still originates with over-the-air transmitters. So we can't simply say, it's a very simple statement to say only 15% of the people receive their signals via transmitters, because that's not true. It's much, much larger than that.
I'll tell you why I asked the question, because I think it's going to be a problem for a while, providing free over-the-air. I mean, there's this whole notion that we have to provide the public access free, and I agree with it.
We should.
And we should. But the digital thing is driven from the U.S., where they're going to take back the analog. They're going to take back the analog spectrum so they can resell it. I don't know that we have to do that in Canada. Hence, why not forget the digital over the air, keep the analog for those that want the free, and just, it's just a thought. You know, I mean, just and deliver digital directly to the express views and the cable. Excuse me.
I've had the same thought. You know, of course, these are my thoughts. That what are we doing here, folks?
Yeah.
For an over-the-air broadcaster to put up a digital transmitter, that means he has to go to the expense of buying the transmitter, number one. There's the antenna and all these other issues. Now you're asking that same broadcaster to spend thousands of dollars per year on hydro just to run it.
But that's driven by the U.S. agenda that says the analog has to shut off because they want that spectrum back. But in Canada, do we have the same demand for that same spectrum? Why couldn't the analog keep going for some time? Does anyone know the?
Just a suggestion. One of the reasons is that we share the spectrum with the U.S. So that within 200 miles of the border either side, we have a big coordination problem with them. So anything we do that would delay the dropping of those analog channels, at least the ones on the high end of the UHF band, would cause them some grief.
But if you could fit them in, you know, because we have a smaller market, then we don't have to put up the transmitters to supply digital. We could deliver digitally by other means and maintain the free access in analog.
I've had the same thoughts, because if you just say, why not entertain that idea and we're just talking here, of just continuing the analog service to provide that free component, and the digital will be delivered through some other means.
Okay. I hate to break in at this point, but we've got to bring this thing to a close. The satellite is going to give you back a few bits and bandwidth at 11 o'clock, so we want to be out of it by that time. I want to thank the panelists. We can continue over coffee and donuts at the end of this and continue the discussion. Just getting to a very good point, actually. I want to remind you that this program is being made possible through the efforts and generosities of many organizations and individuals. Among them are presenters. The CanWest Global System and Fifth Dimension Television have made significant contributions tonight through providing production and satellite facilities and their presentations, and they deserve our thanks. Also supporting us tonight are Sony Canada, who's provided the large screen projector and television monitoring in the studios, and Applied Electronics is the host of our coffee and refreshment break that will immediately follow this program, and I know you want to stay for that. So please join me once again in thanking them all. That concludes our papers for this evening. If you found it useful or you would like to make comments or suggestions, I would like to hear from you. Please write, email, or fax me at David George, care of IMAD ECVS, 3235 14th Avenue, Markham, Ontario, L3R0H3. The fax number is area code 905-470-2559. And email is david.george@imad.com. We'd love to hear from you. We'd appreciate hearing from you, and your notes will help say thanks to our presenters and to all of those who made these programs possible. Also, your suggestions as to future topics would be very much appreciated. Before leaving, I want to remind you of the upcoming Advanced Motion Imaging Conference, February 25th to 27th in Orlando, Florida, and I want to point out that SMPTE is going south in the wintertime. Now, that's pretty nice thought. That might be worthy of another little bit of applause. This conference, which addresses the challenge of change, will include an all-day seminar on system interfaces, networking, and connectivity, especially aimed at the challenges associated with implementing DTV solutions. I encourage you to plan to attend if you haven't already done so. And the next monthly meeting of the Toronto section will take place on February 9th with digital test and measurement as the topic. So mark your calendar, please, and see the meeting notice for detail there. I want to say thanks to those in Montreal who I know are in a pub somewhere quite warm and enjoying the show, for their support and participation, and to our Ottawa members and to our guests, and to all of you who participated wherever you are in any way. And now on behalf of the presenters, the members and managers of the Toronto section of the SMPTE, and from all of us here in the studio in Toronto, good night.